Yeah, everything's fine. Yeah. Often do talks, so don't worry about me. It's like,
Really seasoned speaker. Okay.
yeah. So,
And Slido is working.
yes.
Perfect.
Well, then we have to change to the view. Okay.
And once people start asking questions, we will see them there. And I will ask you the questions. Okay.
Yeah.
How much time do you think it will take to assemble all the parts?
16 minutes?
Yeah.
No, it's I will try to make it match. Yeah, no, we have 40 minutes. I'm just kidding. So I will try to, because I think it's not a data science crowd, so it's more like a developer crowd, I assume.
Hello, hello. Funguje to? Funguje to. Okay. Hello. We have 1 minute to go, so we will wait if somebody else will want to join us in this room in theater. Then I will welcome you and I will introduce you to Alexander, and we will start with a beautiful, beautiful talk on data and pandas. So just a sec. Maybe I will start with some organizational stuff. Maybe the selfie would be better, so you would have the crowd on your face too. Or maybe I can take a picture.
Everybody's not awake yet.
Okay,
I think,
cool.
no.
Okay, so the organizational stuff, you probably heard everything in the previous room, but we have beautiful hashtag PyCon.cz. You can find it on your card when you forget it, so you will never forget it if you will not lose the card. So use it on Twitter, use it on any social media, Facebook, and of course you can use it on Slido. I hope that you all have already the Slido on your phones, because that is the way you will be asking questions in this room. You can ask the questions to the speaker, and at the end of the speech, we will just talk about the questions and have the answers. Okay? The other stuff is we are almost full house. That's good. The other stuff is we have lightning talks in the afternoon, so you can sign up for them. The paper is next to the entrance to the main room, so you can find it there. There are only 7. If you want to speak to the crowd, you don't have much time because the spots will not be added. And the last thing, don't forget to sign up for the workshops on Saturday. Yeah, it's on the website on the same page that you registered for the conference. So that's about the organizational stuff, and let's start with the speech. So let me welcome and introduce you to Alexander, and he will speak about cute pandas and maybe more data analysis. So give him the applause.
Thank you, Eva.
Yeah.
Thank you.
1
Hi. Today I want to give you a short introduction about Pandas, and this is me. I work with a strategic data consultancy in Germany, so we advise startups and middle-sized companies on how they can move on with the data. I'm also an organizer and program chair of the EuroPython and the PyCon DE conference. So first things first, EuroPython is coming if you don't have a ticket yet. Here you go, we have some amazing stuff, and also PyCon DE call for proposals is also open. It will be in October in Karlsruhe. So, Pandas. So now we can go Pandas. What is Pandas actually? And if you're here because you're looking into some cute animal talk, I have to very much disappoint you. I'm very sorry. Pandas is a data science library. It's like the Swiss Army knife for data analytics. It's very easy to work to read in data, mangle your data. It's basically, the idea behind it was you can basically have a lot of data in Python, and if you want to do statistical analysis, before you had to really move to the R language or something else. So something was really missing in the Python ecosystem until like 2008, Wes McKinney came up, hey, let's do something about it. And he built this great library, Pandas, which basically has a method for everything, as you will see. It's now in the Python stack. It's a very stable project. It's now maintained in NumFocus and the Anaconda stack. There are regular updates. There are many contributors. Yes, it's a project you can build on, so it won't go away tomorrow. And just if it stayed the way it is, it would be also amazing. So the main features are actually like support for reading in data from like any data format, you just name it, whether it's CSV, Excel, JSON, SQL queries. You can use it for data cleansing. You can reshape and mangle your data. You don't need really any in-depth Python knowledge to use it. You can basically just like use it from learning it with like basic or intermediate Python skills. It works very well with the Jupyter notebooks, like Python code and visualization in your browser, it's very performant. It's fast. It's very optimized for data analytics, and you will see in a minute. So today I'm going to give you an introduction and a basic overview of the functionalities in Pandas. All the code and examples and the slides are also on GitHub, so it's totally okay now. Yeah, want to? Yeah, so everything is online. The video will be online. You can go. And let me introduce you to the data set we're going to work with. This is our data set. It's a super simple data set. You don't have any overhead thinking about a data set. It's just like a timestamp and a temperature float. That's it. That's all the data for this talk. And we will see what we can do with that. It's from an open data set from Aarhus in Denmark. And let's just like start working with it and let's get the data in. It's quite simple. We just import pandas as PD. That's like a convention. You will see it everywhere online. It's of course not necessary, but everybody does it. And we just read everything in our data frame. I'll get to what a data frame is in a minute. We just say PD read CSV, pass in the path, and set like headers none. And you see this is like the output. And this is also like a screenshot of a Jupyter notebook if you haven't come across it yet. So basically you can execute code in your browser, and basically with the head function, which gives us the beginning of our data set, we can immediately get a printout in our idea what is in our data. So this is really handy for like iterative data work. It's not just like pushing and see some output somewhere else and open another file or something like that. You can have everything in front of you just on your screen. So I just showed you like the convention import pandas as PD. It's how to read a CSV. It's very flexible. For example, just like the read CSV has like 40 parameters you can pass in. I mean, there's a parameter for everything in pandas, which is probably, if you're a beginner, a little bit overwhelming, but don't let yourself scare yourself away from it. But I totally stopped using the read CSV library. If I stumble across CSVs in my day life, I always use pandas because it's much more like transparent and flexible if you stumble across like malformed CSV files. So you can get your data, preview your data, head and tail, just like in Linux. And you can put output to a file, Excel, to an SQL database. But for example, you can also just like read in data and transform it into a dictionary in Python and just continue working with the data in your code. So what else? Visualization is built in as well. So you don't need to think really about another library for this. So you can just use import matplotlib and plotted the stuff in line. And what we're doing here, we have our data frame, and we can access the rows of our data frame, just like with slicing. It's just like the same logic which is behind slicing in Python with lists and stuff. So just like what we do here, take our data set, first 100 lines, and just plot it, and that's it. That's all there is. So it's really very easy to explore data in pandas. And I don't want to go too deep into the visualization stuff. This is just like some basic examples you can do. You have bar charts, you just name it. You can even like improve your data plots if you want to. You can basically just like get the matplotlib object and, for example, add a line. So for example, I added a line here for like, I think the average is like 16 degrees Celsius. Let's see if I'm right later. So basically, and you're not only like matplotlib is well integrated and built in, but it's also easy to plug in other libraries like Bokeh or Seaborn, which are probably like from UI a little bit or from the style a little bit more modern than the very scientific matplotlibs, but it's up to you. Okay, now I told you there's like data frames, and we read everything in pandas into a data frame. So what is a data frame? The idea behind this comes from the R world. The R language, just like the letter R, thinks in series like this. This is like our data. It's like just like 9 data points. And basically, a series of data with an index is a series. So we have a series of data, but it's also indexed. That's very important to know. And what's a data frame? A data frame is just like multiple series together in one frame. And it's at the beginning probably a little bit hard to understand, because if we plot the data, it looks like a table. And if you have a database background, in the relational database background, you probably think in tables. But basically, it's just like you have to think a little bit like 90 degrees turned, like, because this is a series. And the series basically are glued together by the index. So if we iterate, you can of course iterate over like a data series like this, like we use it, you can do in a table. Pandas has like methods built in for this. But it's you can harness a lot of power if you start to think about like, okay, this is like a column. It's still called a column, or in a series, that's like a synonym, it's the same. And work with this, and we'll come to that in a minute. So the data series is just like a one-dimensional labeled series, like data and an index. And the index is not just like numerical, it can be also labels. You can just like put names on it. The index is automatically created when you read in the data, you can replace it as well. The data type can be set while you import your data, and you can also transform it to another data type. We do questions later, I don't know what's like. Okay. So, okay, let's get a little bit more into code and how we can work with our data. So let's just like create like a random series. We just get PD pandas series, just like put in some random values in here, and you see there's like an auto data type, there's an automatically created index, and when we just like plot it out, we always see, okay, this is the index, this is like the random data, and we also get a data type, float 64. And Pandas, why is Pandas so efficient? Pandas is so very efficient because it uses NumPy. So within a series, we use typed data. So we have all the NumPy. If you don't know NumPy, NumPy is a very powerful Python library, which has like comes more like from a mathematical background. It's like for numerical operations, and we work with typed data in there. And of course, like if the data is typed, we can have more efficiency. So so everything is basically some NumPy integer float. Only like text is still an object in Pandas series. So. Okay, let's go on. We can also like say, okay, let's create a series, and we can also just like get some other random functions. We can just like create a simple series and set an index automatically. We can also just like say, okay, we want to have a float. We can be explicit about that, and you probably already guessed it. We can also say, okay, just like do something else. Set another index. For example, I just give a range to like multiples of 5 as an index. And you see like we have some random data and another index. We can also like put just like alpha, any like text labels there. It doesn't really matter. So yeah. So what else? How can we access the data once we have them in our data frame? We can access them as we would do like in a Python dictionary, for example. So if we ask for series A, as remember, A was a label, so we get the value in our series, which has the label A. So this is 71. We can also access it by its index, like position. Sorry, like a position. Like the first A is the first, so we also get the same value. We can also like pass in a list with multiple labels we want to see, and we get a new series back just with the labels which were actually like explicitly matched for. Of course, we can do the same in ranges, like here. We can also just ask for like a position 2 and 4, like everything's of course 0 indexed. And we can also just like pass in a lambda function. So actually just give us back the series with like multiples of 2. So we get B and D, and that's it. So you see it's very flexible. You can be really creative to pull through your data series to get data out. And it's not only like the Pythonic style with the square brackets. You can even also use a method. And this is sometimes stuff which is just like overwhelming if you're new to Pandas. I heard that a lot. So because there's not only one way to do stuff, there's multiple ways, because we also can use a method. We can use a method. The method is lock. So just like lock, search for an index label, and we can use ilock, like for index positions, and just like get the data back, and for example, just like immediately plot what we get back here. So we do an ilock, give us like these 2 values, and we get this amazing line charts with 2 values back. That's powerful. There's also, or there used to be IX. You might stumble across it in like code examples. IX is basically just like a lazy function. So if you don't find anything in ilock, in lock, it will look for ilock, and just like that you know, because with the most recent Pandas version 0.0.2, it was deprecated now. So don't use it. It's just like confusing, because usually you know how your data series is labeled. So what else? If we have a series and we often want to know what's in the data set, because you get some data set and you series.name and set some string there, and you see once we have a printout, we see our name here, our series now has a name. Basically, this would be like the synonym to a column name in a table. And often, like in the Pandas world, although we have like data series and data frames, still very often it's referred to as rows and columns. So don't worry about it. So you know the very basics, how Pandas basically works, how it's set up, how you can slice data, access data, and let me tell you a little bit more about Boolean indexing. So what's Boolean indexing? What do we actually do when we ask for these two labels? A Boolean index is just like a vector of 0 and 1 values. So basically, imagine you have a series, and you basically query a series in Pandas. You get returned just like a true value array. And then you can ask the series, please give me back the positions where we have a true value. That's it. That's all there is to know with Boolean indexing. So what's a data frame? A data frame is now a two-dimensional labeled data set. It can contain data series, as you remember, when I imported it, there was just like 0 and 1. It was just like there was no header provided, and I think it's much better and much more readable if our data series actually have names, because we actually can ask for them by a very explicit name and not just like, okay, take the third one. Yeah? It's much better to ask for, give me back the temperature. So I just like, renaming is really simple. You can just like passing a list. And so we have now, which is still positional values, a timestamp, which is still a string, and the temperature. And we can just like plot the data. So we have that already. So what else can we do with that? When I travel to the US, for example, I always have a lot of trouble with Fahrenheit, because I don't have like a natural feeling for how hot is Fahrenheit. So I thought, okay, probably there's some rule of thumb. Let's define a function for that. This is like the Celsius times 9 divided by 5 plus 32. That's the official, that's the how you can basically get Celsius to Fahrenheit. And let's see whether we can make up some rule of thumb for like regular temperatures, where we can see like, okay, 99 Fahrenheit is probably language. So take an array and apply this function to each and every value we find in this array. That's a map function. So we just map to Fahrenheit. We see, and basically it does look quite good. So let's see whether we can get a little more sense into that. So basically we just, because if we do something like that and just like ask for temperature and ask maption, we get a new series back. It's not automatically added to a series. So let's do this, and basically we can just like add a new series to our data frame, just like we add data to a dictionary. Just spec records, choose a nice name for how we want to store the series in our data frame, and that's basically it. We added a new column or a new series in our data frame, temperature F, which is basically doesn't look that bad. So, but no. And the same, we don't need to do like define like an extra method. We can also just like apply a lambda function. Yeah, it's just like the same. We're very flexible, but it's the same idea. So let's see how far we can get with our rule of thumb. So let's create another data series and just like see, for rule of thumb, I want to have like something easy I can divide or multiply by. So we have now like, we can take these two series And since the series, we can do calculations as if they were like vectors, and we can just like divide them by each other. Because of course, since we have the index, they will have the same length, and we can just like divide the series, and then each and every value is divided by each other, and we get a new, as out, we save our output to our rule of thumb, and that looks quite good. Yeah, we could say like, oh yeah, let's settle for 4. That's not too bad. And if you want to get a really like a statistical impression of how good our rule of thumb might be, we can use the describe method, which is also built in. And we just like take the series and ask describe. And a little bit more background on in the statistical world. We, of course, everybody knows like what a count is, what a mean is. We also have like a standard deviation, so how dynamic is our data set. That's a statistical value. The minimum value in our rule of thumb is like, it's 2.9, we get a minimum, maximum, and we also get like the quarters, which is basically like the distribution. Basically, think about it, how is the data distributed if you put it like in 4 buckets, and that's like the 75%, so more than 4.2 is like the value you find like in the upper 75% in our data set. But we also see we have a maximum here, and this is really off. It's like 17 like as a maximum, that's a 4. We just settled for 4. Yeah? So let's look a little bit deeper and see, okay, we already saw like maximum 17. I think it's a bad rule of thumb, also from what we just learned from our distribution. So what if we think, okay, let's be explicit and rename our data series, and we can also do that just like by the rename function. We can just pass in columns in a dictionary with the old name or the new name, and that's also like a big caveat, you have to put in place true there, because otherwise it will just return a new data frame or data series to you. And if you want to store stuff in the data series or data frame you're currently working with, you have to pass in place true in there. That's a caveat for beginners usually. So of course it's a bad rule. Let's get rid of it so we can just like drop it. And also same logic applies. If we drop it, it returns basically a new data series of frames. If we don't explicitly instruct, do this operation in place. So we got rid of our rule of thumb, and probably I get an app for that now. So what we just learned is like how we can modify and data series and data frames. And the important thumb, I cannot like really push this enough. Think about in place, the in place, passing in place true if you want to apply the changes to the data set you're working with. Of course, you can also just like take the result, store it to a new variable, or just like the same name. It doesn't matter. And we also learned we can remove data series from our data frames. And so let's move on what we can do with data aggregation. So I hope I'm not too fast, but I want to show you a lot of stuff. So let's do like a group by. A lot of the thinking in Pandas and like the names is coming basically like from SQL logic. So a group by in Pandas is just like the same as you would do a group by in SQL. So basically we just say, okay, take all the values in our data frame, group them by temperature, and count. And what we get for each and every value we find in the temperature data series, we get a count how often timestamp and the temperature Fahrenheit appears in our data set. Of course, these values are all the same, but this is just like for demonstration. So, what else? We can also like see what's like the deviation between temperature Fahrenheit and temperature Celsius. We can also do this by like a simple calculation. We can just like add a new data series to our data frame, and just take one series and subtract the other series, and we immediately can subtract the mean from that series. So, and pass it in. So we see, okay, there's sometimes like really big differences. So, and of course we can also just like take the result there and just immediately plot it.
Okay, our time is run out a little, so we have 4 more minutes.
Yeah, that's fine.
And we have one question so far, so
okay.
It's okay.
All right, so let's see where we are. So, okay, let's speed up a little bit. Of course, the scribe I showed you already. I really want to get to a little bit more on this. This is, you can just look it up. Okay, this is what you learned. You have describe, group by for data aggregation. And just like let's a little bit peek into null values. You can just ask, are there any null values in our temperature data series? With just like asking is null, and we get like, oh, okay, we actually have 4 rows there with none values. And so probably we should get rid of them, or if we're in a statistical world, probably we want to have them replaced by some own logic or just like the average. So we have 2 values, one is missing. Okay, let's connect them via the average. That's like a statistical method. We don't have the time to go too deep into that. So my main message is there's like 2, for example, you can just like say, okay, drop an A, you can just like remove all null values from your data frame. And the same applies, of course, only if you pass in place, true. So that's basically like the end of it. So part 1 usually is a part 2. This is a huge cliffhanger. We learned about data series, I/O, data analysis, indexes. You have built-in visualization, and this is just like the tip of the iceberg of what's built in Pandas. So just like to give you a small peek for another like minute. Oh, I see.
We have 3 questions.
Thank you. Thank you for another minute. Thank you. Of course, if you have questions and we can't answer, ask me later. I'm around all until Friday. So. Let's take a little peek how we can, for example, work with the index if we create from our timestamp data an index. So we can just use another built-in method to date time, and we have these nice timestamps. Be aware, this is a little, of course, US date friendly because McKinney is from the States. So, you know, like US tends to have month first, then day as the only country in the whole world. So it's a little US date friendly, but sometimes it's European friendly because the weekday Monday is 0 and not Sunday. So there's sometimes not 100% US timestamp logic built in, because of course Pandas has many maintainers from everywhere. So let's create a time series index. So we take the timestamps, make them into an index, and what we see, this was our timestamp we've plotted, because actually like the timestamps were for multiple sensors and they were unordered. Once we have an index with a timestamp, basically a timestamp is just like a number. Also, like when we plot the data, we get it back in an ordered fashion, and actually, if you ask me, this is like very horrible, like up, down, up, down, up, down, and this is more like, okay, yeah, this looks like temperatures over the range of the day. So this is like only a glance on the very much power on Pandas data views, and you can do like amazing stuff like this. Also just like ask for day values, or for example, check whether the weather on weekends is better or worse than on weekdays. But you can watch the slides. The code is online if you want to try it yourself. If you have suggestions, just ask me. And yeah, that's the end.
Perfect. Okay. Thank you very much. Can you hear me? Yeah. Okay, good. We will have probably quick question number 1, which was upvoted. So what data do you use with Pandas, or what would you recommend?
Usually I recommend always use PyCharm, except for Jupyter notebooks.
Okay.
Basically, what I do is do a lot of coding. For example, like implement methods and stuff I put probably in the library folder. I do that in PyCharm because I think it's the best IDE around here. But for like, if you do like if you want to explore your data set, I do it in a browser with Jupyter notebooks. And what I usually do, manage everything via PyCharm and have PyCharm keeping stuff together, but go to the PyCharm console and start Jupyter notebook, just like putting Jupyter notebook and do the rest in the browser. Because like Jupyter notebooks, they're built in PyCharm, but the implementation is not really good. And I also talked to the guys at JetBrains, and they said, yeah, well, the Jupyter project is moving so fast, they just cannot keep up with it. So, because usually they do a really good job. Yeah. So, yeah.
Okay, perfect. Thank you very much. And I don't know, Sandra, are you here already? Okay, Sandra's not here, the next speaker, so we will have time for one more, and then we will thank you. So, what are the limitations of Pandas? What cannot be achieved with Pandas regarding data analytics?
Who asked the question? Like, what's the limit for you? Is it like data size, fast?
Please, could you raise your hand so I will give you the mic if you want to ask the question? Okay.
Yeah. Usually, what's like Pandas says it's really good up to 1 gigabyte of data, typed data, not just like Python objects data. It says very good. I also use it with bigger data sets, but I think with like if you have like a data set with like 10 gigabytes or so, it starts really to get a little bit ineffective. You can think about probably if you have a larger data set to do in a streaming fashion, just read in the data set and just like keep an aggregate and basically get to what you want to achieve there. Also, Wes McKinney is I think one of the contributors of Apache Arrow, actually addressing the issue a little bit deeper, and I'm sure they will connect everything if it's not already. I have not time to look into Arrow yet, but yeah, but that's it. So like 1 gigabyte, below this up to 1 gigabyte of data, you don't really have to worry about it, and even if it's bigger, it's still okay.
Okay, excellent, brilliant. Thank you for the answers, the questions. You can catch. Thank you very much, Alexander. It was a really good speech, and we have one surprise for you. We would like your autograph here on the PyCon stool. So if you would just, here's the fix. Yeah, the marker.
Okay, just like here.
You are the first one, so you can choose any place you like.
Just.
Registrace na workshopy. Lidi si registrují na víc než 2 workshopy. Registrují se. Oni se registrují třeba na 6 nebo na 4. Podle mě, protože to není jasné, že tam dopíšou ty časy, ale až se podívají. Vlastně jako by už na 20 minut mají do programu. A podle toho si vyberou. Tak to není, tak tady ten průvod, no, jasně.
Yes.
Nemám tady next speaker.
Jo.
Já naženem, ale...
Ona se sem snažila dostat, ale ona je hned za dveřma.
Jo.
Ale snažila se sem dostat, ale jak tady byla ten dav, tak vlastně čekala zase venku a teď se asi bude to. Takže jediný nějak protáhnout zadem ještě.
Tady. Pojď protáhnout, to bude... I think it is better if you want to go this way. Because, okay. Yeah, I'm sorry. Something special? Hello, Anita. Yeah, nice to meet you. Good. You can have both, but I think that HDMI will be better. So this one, yeah. Woohoo. So maybe the guys in the back, if you want, there are some seats over here. So if you will go forward, you can get some space. I'm really thrilled that there is so many people wanting to join us in this data analyzing session. There is a red cross on the floor. Yeah. Because the camera is targeted. So try to keep around this place, and you will be in a good shot. Yeah. Do I need a microphone? You will have the. Go away! You can do whatever you like afterwards.
I will just mic for you. Are you reminding folks about the lightning talks?
Yes, I will. Okay, guys, before we will set up for the next talk, I have another organizational stuff. We are thrilled that a lot of you started to register for the workshops, but mind that there are only two simultaneously running workshops. So some of you registered for 6 of them, and it is impossible to maintain. So maybe check which workshops you actually registered for, so you will be able to really get to those. So that is just quick heads up. And the other thing is, I hope that some of you already signed up for the lightning talk, and we will be thrilled to hear your stories and what you want to share with us in the afternoon. So these are the 2 things.
Excuse me, where do I register for the workshops? Do I have to sign up?
Yep. For the workshops, you can register on the website where you purchase the tickets. The workshops are for free, but there are limited places. I think that 25 to 30, so be fast. Okay, maybe post it.
We just wanted to make a test.
Yeah, okay. So we've already tested everything, and I think that we can be ready for the next speech.
Okay.
This is Sandra.
Yeah.
Yeah, let's start.
Okay, hello everyone. I will present me really shortly. I'm Sandra. I'm actually from Germany, but I live and I work as a data visualization freelance in Spain, in Madrid. And I don't want to talk a lot about me because I have so much to tell, and we have only 30 minutes, as I know, so I will try to talk also really fast to give the most of it to you. But I'm really happy to talk after the talk with you. If ever you want to chat about something, I will be around. So, visual storytelling. I mean, I can't see you anyway. I wanted to ask who knows about this topic, but as I can't see you, I will just start. Okay, most of the time we have the situation that people come to us, let it say in the business world, in the university world, that we say, okay, tell me something new, something interesting, but actually I don't have time. So the problem is we need to do it really fast, no? And on the other hand, we have so much data. But you can actually, with the visual storytelling, you can just say, well, here it is, here are the data, just look at it, there's the story, there you get it. Okay, so now you say, well, that sounds really easy. And it's, of course, not so easy. And the thing is, if we only focus on data, that's why some people also call it data storytelling. We actually have the problem, I mean, I assume you're all Python programmers or you work with data all the time. If you just look at these tables, you won't see anything. And because we are living in a world of big data, we even are more lost. So that's why it's actually the visual part which makes it so interesting. And that's why we call it visual storytelling and not data storytelling. So what are the objectives? Well, the most important objective, I think, is always, as I said, all this data is absolutely nothing if we can't get the story, no? But we have different approaches. So in the business world, it's most of the time showing results. And I will, just to let you know, I will make a mix of, right now I speak a little bit more about the theory, but I will show you a lot of examples, because this is something you learn only if you look at examples. And if you look at all the really great ideas the other people already had and they put into practice. So this example I will show you later. And then, of course, the most interesting part of the visual storytelling is actually to explain our complex world. And I don't know if you have seen this example, because I think it's one of the most famous ones in the visual storytelling world. And who has, well, I can't, yeah, you know this? Okay, and you like it? Yeah, I guess so, because the thing is, you know, I assume the audience here is familiar with machine learning, but most of the people are not. And most of the people are afraid to even ask, because they think, oh my God, if I ask, then people will explain this to me in a really complicated way, and then I even understand less. So with this visual storytelling, what they did is they made a small text. Okay, we need still text, but actually only looking at the visuals, we understand what's going on. And in this example, they said, okay, what's the difference between houses in San Francisco and New York? How can we analyze this, no? And the first thing is always intuition. So what do we think? What's the main difference? And they say, okay, because San Francisco is so hilly, maybe it's the way, maybe it's the way houses are created. So just looking at this, we see, okay, intuition seemed to be a good start, but the problem is we have so many data and we have so many variables, and how can we be sure that it's really this? So maybe we should add a new nuance, no? So what we see in the visualization is directly representing what we are doing in our thoughts. So we go one step further and we have a new layer, so we have new dimensions, and then what we see is, okay, we have the price per meter and we have the general price, and we see, okay, here are some houses which are really easy to characterize in the San Francisco world, and then here we have the New York, so we can draw the boundaries and we see it directly visual. But this is also not really enough, because we have so many variables. And I don't want to tell the whole story now, but what I really want to show you is that just by looking at the visuals, you can actually understand the whole flow of the analysis and of the thinking. So now we have what he's saying, let's switch the boundaries. And can you see how the visual is also switching? And then he's saying, okay, the problem with all this is we want all this information, but we as humans, we can't process all this information. And that's why we actually need the machine learning, no? And then he explains how a decision tree works. So in a really easy way, first, so just say, okay, let's take the first variable and say how many houses in New York have this value and how many in San Francisco. And you see, let's focus first on this side and then on the other side. And then, and this is the best part of this project, is we build the decision tree visually, we see it, and we go down, down, down. And then, of course, what is new in machine learning is that we actually use training data. And how can you visualize training data? So just by this, no? You just let your data flowing in the model you created. And so what I want to show with this example is how all the visuals are really explaining already the story. And they go step by step by step. So this is one example to explain models. But then, yeah?
There's something similar with neural networks, where they understand.
I can actually, I don't have it in this presentation, but in another presentation, there is a new field of visualization which is called algorithm visualization, and it's only visualization to explain algorithms or to explain complicated. And there is a web page, I think it's called Explain Visually, and they have already they have 20 projects, and maybe there's one, I don't know if there's one about neural networks, but I'm sure it will come soon, because this is a new field which is growing every day. And then we have also, it's not only explaining, showing results, it's also provocating, yeah, because we use also visual storytelling, we use it a lot in the data journalism world. And this is a wonderful video, which I can't show you now because it's 20 minutes, but you have to watch it. There's no way around it. And it's actually, I don't know if you know it, it's about the Second World War, and it shows visually, so if you, I don't know if I have the, no, okay, cool. So you just see all the time what's happening, and the guy is actually talking. Well, yeah, I don't know. And you see with all the visuals all the time showing what's happened in the story, but the story are only data, and the data is only represented by humans because it's about how many people died during the wars. And it's a really wonderful video to reflect about, oh my God, what happened in these years. And also, I think what most of the people don't realize is what a wonderful world we are living just now, making a comparison. And there's 1 minute, the 6th minute, you have to watch it because it's really, it makes you really emotional. So it's also about reflecting about the topic, yeah, and provocating. But in general, the idea is always to improve the communication, because the problem we have is we have data and we have data scientists, but most of the time the data scientists are doing the models and they process the data, but then we have other people taking the decisions. And the problem between these two guys is that they don't understand each other, no? And I think they don't want to understand each other, which is fine. we don't need to get along with everybody. And that's why we have visual storytelling, because as I showed you, the machine learning example, you can show it to a data scientist and he will be fine because he feels familiar with the statistics he sees. And you can also show it to a business person or to a marketing person, and he will more concentrate on the, on the colors or on the general flow of the communication. Yes.
Why can't you make data science?
Could you write the question into Slido?
I can't connect to the internet.
The internet.
Oh, I'm sorry. So, actually.
Sir? For me, it's fine.
Why don't you make data scientists to do decisions?
Well, because my experience is most of the time these people don't want or they don't know how to explain. This is most of the time the experience. I have a lot of friends are data scientists, and I teach also, and when I ask them, do you want to teach? They're like, no, I like only to do my models. And on the other time, I understand this because it's quite difficult to be in this complex world and translate this complex world into a world which makes it understandable for everyone. This is a skill on its own, which we see here. I can show this example. I don't know. You might be able to do this decision tree, but you might not be able to do this visualization, which shows how it flows. Does this answer you? No. But
Ask you later.
I'm sorry?
I will ask you later.
Yes, I think that's because there's so much still to come. Okay, the audience, of course. Most of the time, all these examples I have here are internet examples. So if you produce something for the internet, you don't know really who will watch it, no? But if you already have some knowledge about, so for example, I had the feeling that at this conference, the people will know a lot about programming and analytics and less about the marketing part. So I take this into account and try to adapt my presentation and also try to adapt your visual storytelling in this way. Use colors, use things people feel familiar with, And on the other hand, expectations. This is something which also goes wrong so often that in the data visualization world, we have most of the time, people are just calling for dashboards. And they do dashboards with 100 variables, because I feel sometimes in data visualization, we are still behind. We are at this stage of, we can do everything, so let's do everything. No, this is not what we need. We need actually to put ourselves in the user and in what do they want? Do they want to explore things, or do they just want a number and say, okay, this is the final prediction, for example, and this is the only thing I need to know. And visual storytelling also adapts to this. I show you now some concepts how you can adapt to these expectations. So how do you create? It's actually really easy, because there are only 4 steps. And nearly all the examples have these 4 steps. So the first thing is define the context. Where are we? If we go back to the machine learning example, the context is just, okay, I want to introduce to you machine learning, but I also have the question, what's the difference between houses in San Francisco and New York? Okay, that's the context. And it's important to say this, because some people just start directly explaining numbers, and then you feel lost. And then the second step, which also so many people forget, is making the easiest example you can think of. Because our world is so complex, and we also want complex things, we sometimes feel like overwhelmed. And when you start a story, so you're in the context, and the first thing is you need to just get the people with you, and feel like, oh yeah, I understand it. So for example, in this, coming back to this example, the first thing is something everyone will understand. It doesn't matter if you're a statistics person or if you're because it's something human. And this is really important to connect with the people. If you don't make this step, so many, I don't want to, but so many people in general forget this step. Yeah, they just start directly, our model, blah, 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 and people are totally lost because they don't even understand what is the model about. So really start really easy. And then you need excitement, because if you don't have excitement, which also happens so much, I worked in quite a lot of companies, and I've seen this everywhere, all over the world, in different companies. They just show 100 charts, the same thing. So now these are the numbers for brand A, brand B, brand C, and I don't know, the people are sleeping in their heads with the eyes open. You see it, because there's just no excitement, and there's no, what are they talking about? Okay, so this is when you just do easy examples all the time, and you just repeat. So you need excitement. And how do they do it here? Well, they go step by step, but then they have this, okay, and now machine learning. This is really like this. Okay, here I'm fine, and now, oh my God, now it will happen, no? It's like, how can I get prepared? And then later on, they do the same stuff again when they say, let's make the reality check. Yeah, it's like also something like, okay, now let's use this and see how it actually works in the reality. And then the final step is just a resolution. So also not letting the people in this creation, in this excitement, but taking, in the end, all the information you had and make a summary, which sounds maybe also quite simple, but most of the people forget this step as well. And they do it actually, in this example, they do it in a really easy way. That's the only criticism I would have, because they just make a recap like this. You could do something more visual in this way also. Okay, so these are just the 4 steps. And then, well, this really quickly, in the practice, we have 2 types of people that should work together, which is also something, why now it's changing, but in the past we had most of the time, let's first analyze and then visualize. And this is also, and that's why we have so many dashboards, because people only think visualization is in the end, to show some numbers. But actually, the most interesting part is if these guys work together, because then you analyze, you visualize, and you analyze again, you make changes, and you visualize again. And with the visualization, you can actually analyze. Okay? So the language, what do they use? And what I see now is, I'm in the visual storytelling space, let's say, already for 2 years. And the first year was quite boring, because it was just what we already know in presentations, do it in a web page. But what is happening now, people becoming more and more creative, no? And what we see is that people really start using visualization as a language. So for example, this is a wonderful project. What he does is he said, okay, there are a lot of different like these art books, for example, and he tried to transform it into visuals, which tells the story of this book, let's say. And what he did is he said, okay, let's take the whole text of the story and make colors represent the people by colors. So we have to think, okay, in our story we have actors, and in visualization we have visual encodings. So how can we connect these two? And he said, let's give every person, every actor, a color. And then what he's saying, we put it in a line so that you see visually, it's again, yeah, okay, the text is what is happening in the story, but how can I represent visually what is happening? So I want to show the length of what one person is saying. So I just put it as he shows here. I put the whole sentence together and make it like a line, yeah? And then you see the whole act, and if you click to an actor, you can see, well, maybe it's a little bit slower. Yeah, and then you can see where this person is represented in the story. So this is a really nice way of really translating I don't know, a book or whatever, into something visual. So we only have the visualization there, which is showing the pattern and the representation of the actors in the book. And the nice thing is, once you've learned, this is also something quite new, you have to learn these new visual encodings, then you can actually compare. And you can see that, for example, in the time machine, you see that there is just really a few actors, and there's just one who is dominating everything. And because you translated these books or these stories actually into visuals, you can now compare them easily once you've understand the visual encoding. Yeah, so one way to really find a visual story is use colors for your actors. So choose the variables which are most important, the same they did here actually, and they did it in a really subtle way, how they introduced their actors, because they only used colors there. You see, like San Francisco is green and New York is blue, and then they never ever mentioned San Francisco and New York in the visuals. This is like minimalizing also the information you have. And then you have another way to speak with visuals, and this is like using shapes for events. So this comes actually more from the infographic world. I assume you are familiar with this. So what you do is you create a visualization, whatever. So in this case, for example, it's the holidays of this person, and you have the different months, and then you go and see if it in which month it was and in which year. And then she uses here some icons to actually show what is happening. So if she went with her father or with her boyfriend, or if it was with others, if it was a sunny holiday or whatever. And this is really nice because it shows us what is happening in terms of events. Because we have stories, we have actors. Most of the time we can use colors. And then we use shapes or we use icons to show events in our story. Yeah? And then the most important part is actually patterns are stories. So once we have done a really good visualization, the nice thing about us as humans is we always try to find a reason in the things we see. So if we see a visualization, we always try to directly understand, why is this outlier there? And this is already a thing. Most of the time people delete outliers. Outliers are actually a really nice source of stories if they are not if they are not a mistake. But sometimes there is something going on. So looking for patterns is the best way to find actually your stories. And we have here another example where this guy, he visualized how he played the game Scrabble with his father and his mom in the last years. And he explained, this is also what I mean, this is this new type of visualization. So you use absolutely new visual encodings, which he explains once in the beginning. So he says, okay, a high score is if the line is really long and if it's a really big point. This is a high score, no? And if it's a smaller line and a small point, that's a small point. And the thing is also what you see here, it's called redundant visual encodings. This we see in visualization also a lot. Most of the time we don't like redundance, no, in our world. In visualization we like it because it makes it even more easy for us to understand things. So if we use two visual encodings, like the length and the size, we will understand and see patterns even stronger. And so in this case, we see, for example, at this game here, there was something going on with him, no? He made 4 really, really good moves. And like just showing the whole year, you understand, I mean, it's a funny thing. It's not something related to business, but I think it's really nice how you can visualize and then make a story around how we played Scrabble, no? And then he has some more visualizations, how to show who has won, and so on and so on. But what you can see is just by visualizing it this way, you are able to discover patterns. And another really nice example is this one, where they decided they wanted to show the structure of a city, but represented by the geographical view, but mainly focusing on the roads, you know? So they defined here their visual encodings and said, okay, we only use colors, actually. We make it really simple, and we have only colors. So we have the main roads are the red ones, and then the less important, they have more orange and pink. And they show here how they made it. You know, they looked first and what's the general geographic representation, and that they tried to extract the most important part and then apply the visual encoding, so the learning. And when you then understand the visual encoding, you can then just compare easily all the different cities, and you have a pattern for all the different cities. And you can see all this information combined. Okay, concepts. So this was how we created, this was the language, and now there are some different concepts. So in general, we have 2 extreme ways of telling a story. One is, I'm the author, and I just want to tell my story, and you understand it, and you follow me. The machine learning example is absolutely author-driven, yeah, because we have no interaction. The only thing the user can do is scroll. Yeah, I can't change the story. And on the other extreme, we have the viewer-driven. And viewer-driven means the author only presents me a visualization and explains to me how the visualization works, but then I interact and I find my own stories. So that's why author-driven is one story. There are different messages, but it's really linear. It's like a book or it's like a movie. It's really linear, and it's really efficient. Yeah? So if I really want to make a point, then it's better to just use something similar to the machine learning, or the video, the fallen video is also really author-driven. But if I don't know what's going on, and I actually would like to make use of all this world and all the people that are in this world, I create an interactive visualization and let it go out, and let's see what the people come up. So it's discovering story. There's no message, it's non-linear, and it's interactive and open. And within these 2 extreme approaches, we have 3 concepts right now. One is called, it's called storytelling. I come to this in a moment. It's really author-driven. It's like the machine learning example. Then we have on the other side, the other extreme is drill-down story. This is, I will explain to you, but let's say it's really an interactive visualization. And in the middle of them, combining the 2, is the martini glass structure. So let's start with the storytelling. Why is it storytelling? Well, actually, it's because they made a study and they found out, I don't know if you remember, but in the past, the visualizations we had, they were most of the time with click. But the problem is we are really lazy. And even a click is already too much. So the people don't click. Yeah, so they, oh no, I don't want. I just go to the next page. But if I have scrolling, this is also interesting. We have this inside of us, we want to see the end. We can't stop. We want to see what's happening in the end. So that's why now everyone, I mean, you know, also the web pages, everything is with scrolling, no? Because it just works better. And in this field, they use it a lot, this approach, sorry, they use it a lot in the data journalism world. I don't know how much time I have, that's why I... It's okay. Yeah, okay, I will go. Okay, then just to let you know, this presentation is public, and all the pictures have links to the examples, so you can always check them also later, yeah? So in the data journalism world, well, just to make it short, because talking is not as efficient as showing, is you see, like, for example, in this, they said, okay, how many liters of water do we use every day, no? And then they use like these kind of visualizations to show how much is it really, no? And then the story goes while you're scrolling. And then, okay, they understand, and then comes the next one, and so on and so on. And then there's actually a new approach which is called visual essay. And it's structured as an essay, but we have all the time the visualizations that makes the story flow, as I don't have so much time. And just this example, because it's wonderful, and it's coming also from the analytics world. It's like, now, what's this? Okay, it's like a typical prediction model, no? For, okay, what is actually warming our world? And most of the time in this, people do prediction models and then they just show, I don't know, the numbers or whatever. And I think this is a really nice way to show how you can visually tell the story. So this is our line. And we see clearly, because we are all understanding lines, there is something going on. It's going up in the last years. Something is going up. So they start using different factors they thought that would influence in this. And what they use is they just show how the lines involve. And then and this is the interesting part, because we all understand visuals, we all understand that this line has nothing to do with this line. So we can all understand, but just by looking at the visualization, no relationship. And then he's doing the next thing. And you see, this is also the easy example. As I said before, no? Context, easy example. And then he said, okay, it's the sun. No, it's also not the sun. And then it's Valkonans. No, it's not this. Maybe it's the three. So now he's creating some tension, yeah, some excitement. Maybe it's all of them together. No, also not. And then, well, this is for me a little bit the boring part. He's actually going on with this, which I think is not so useful, because you see the story is actually not so going so well. But then, suddenly, he realized, oh my God, it's the greenhouse gas. And this is something we wouldn't have expected, no? So, and you see, or some of us, I don't know, but what we see is we have the two lines together. And I don't need to say anything. I don't need to say there's a relationship, because we understand in a visual way there is. Okay, so this is, and then, of course, the final thing is bringing everything together. To end the story, we have to bring everything together. So, and then we have the Martini glass structure, and this is just combining the two contexts, the two concepts. So we have the context, we have an author story, and then we open our visualization. Is it? Okay, then you have to watch the presentation online to see it there. Actually, there's so many wonderful examples, I don't know. But then just, do I have to finish now? Then I just want to see show them the video.
If we want to watch the video.
Yes. Okay, you have more examples here. Go inside of these examples. I mean, also contact me if you want. I give also courses if you want to find out more about this. Just the must-have. Every visual storytelling needs personalization. So speak about what is important for you, how you feel. Then beauty, don't forget this. So many people forget that we like to see good things. We don't want these car-crashing colors anymore. Yeah, so make your visualizations beautiful. And the last thing is emotion. So we need to connect emotionally. And there, have you seen this video? One person? Okay, then it's fine. This is still one of the best visual storytelling examples. And what it does is, I just need to explain shortly the context is, okay, they wanted to provocate reflection on how many people die every year just by using guns in the US. And so they made a lot of analysis, what is in the data. But then suddenly they realized it's actually not what is in the data, it's what is not in the data. So what they mean is they made an estimation of how long would a person would have lived if the person would have not died at this moment. So they created a line saying this is the life of a person. And when this person is alive, the line is orange. But then when this person was killed, this person would have lived, because we can estimate it with statistics, so this person would have lived longer. And then we see the line going. How many lives are lost? How many years of life are just lost because of the guns? And in this example, I want to show you just because it's really nice how they connect with the user through emotions. Okay, how do we do?
Just play the video.
But maybe, I don't know if you see it, because it's really black, everything. You can't switch off the light, no? Well then. Okay, then enjoy. I hope it's loud enough, because the music is important. Yeah? I don't know. Can't see, no? I can't really see. Well. Yeah. Well, you couldn't see it so much because it's really dark. But now he's showing how to interact with the visualization. So this was this martini glass. And what you've seen is these lines and lines and lines. This is actually scaling emotion with visualization. Yeah? It's like making it bigger, making it faster. This is something emotionally that affects us. Okay, so if you want to know more, I don't have more time, speak to me, and thank you very much.
Okay, yeah. This will work. Thank you very much for a beautiful speech about data analysis and visualization. We will have time for 2 questions. Sorry about that, but this was important. So the first question is, what program do you use to visualize the data? Why is it so beautiful?
You ask me?
Yes.
Well, most of the time I use D3, and we are really expecting Express. I don't know if you heard about this. But there's also Kato, which is really good for maps. I don't know if you heard about Kato as well. Because the good thing is, I like, as everyone, I guess, like we want to personalize it. And with things like Tableau, you can't really go into it. You can only visualize what they provide you. Mm-hmm. And with D3, it's quite difficult because you have to learn all the programming. But with Kato, you have the possibility to interact with the interface and also see the code. So, and well, then you have for network, you have Giphy and other. You have actually already tools for everything.
Okay,
Yeah.
perfect, thank you. And the other one will be dashboards are cheap. Okay. How much time should I allocate to storytelling prep versus analysis?
Sorry, how much time should I allocate to visual storytelling preparation and analysis? Wow, well, this depends on a lot of factors, I would say. In my opinion, it's more important, we call it the UX factor of visualization, and this is actually today more important than the creation. Because most of the time what we see is they create dashboards, but nobody uses them because they just get lost. So right now, for example, it's the first time that I got also jobs just to do visual storytelling. They have the visualizations and they want me to not redo them, but to say what's good and what's bad. This is quite new, I think, in this field. I don't know, it depends a lot on the project.
Okay, perfect. Thank you very much. Thank you for the questions. I think that there will be some time to talk to Sandra afterwards. So if you will have more questions, just connect with her.
Yeah.
And I will thank her and say goodbye for now.
Okay,
So
thank you very much. Yeah.
Thank you.
I will ask you.
I think that's ready. There is the cross that you shouldn't cross.
Okay.
Because there is the camera. So, okay. Before we will start, after this talk, there will be lunch. To lunch, you will get through the staircase. It's upstairs. It will be huge and it will be good, so I hope that you are hungry already. But now you should be hungry for more information, and that will be about some secrets in Python, I guess.
Yeah.
So here's Moises, and he will take you down the road with the secrets.
Thanks,
with Wolfgang. Yeah.
Hi, everybody. Does this sound good? Okay. My name is Moises. I'm from Brazil. This is my second time here in Prague. First time as a visitor, now as a speaker. And this presentation, I will talk about a Python module that I made up. I'll talk a little bit about myself. My name is Moisés Guimarães de Medeiros, a big name, but a Brazilian name. I'm a software engineer at WolfSSL right now, and I'm also a professor at the Federal Institute in Brazil, where I teach high school students and graduate students how to program. My background, I have a technologist degree in web development and a specialist degree in security. And when I'm not coding, I'm playing some music, playing some games, or doing some sports. And this work I'll present is a module made by WolfSSL. This company was founded in 2004. Back, we had a SSL implementation in C++. It was used by MySQL. And then we got rewritten to C language for embedded devices. The company was rebranded to WolfSSL in 2013. We now have 26 employees and 18 engineers. We are spread all around the world. We have, most of our guys are in the US, but we have people in Japan, Brazil, Australia, and now we are hiring people in Europe as well. And we have secured over 2 billion connections, and we have a lot of customers using our products right now. So, I will talk about WolfCrypt. WolfCrypt in the C level is a lightweight C library. It's the core engine used by WolfSSL to encrypt and decrypt data. As WolfSSL is the protocol layer of our product, WolfCrypt is the crypto engine. It's widely used by the IoT market and also available for desktop and the cloud. So we are basically everywhere we can port to. And we are famous by our small size, mostly. So encrypting is all about secrets. I have a bunch of secrets. Who else does have secrets here? Okay, so let's keep them safe, yes. And in the beginning, so how did people start to protect secrets? It's like in the ancient, there was 2 basic techniques. Transposition, where you switch the position of the letters inside the message. So we have this kind of rod, and then you wrap it around with a stripe of letter, and then you write your message. When you roll out the cord, the letters will have changed place. And depending on the diameter of the rod, the message will not fit if you have to have the same diameter to roll up again and read the message. And we have substitution. When you take one letter and replace it by another letter, one of the most famous ciphers known as the Caesar cipher, where you exchange letters from like A will turn to D. The key is 3 letters forward, and then to decrypt, you would move 3 letters backwards. But nowadays, basic substitutions most use it like ROT13, just to avoid spoilers. And nowadays, we have evolved in the crypto solutions, and it gets pretty much complicated. In Brazil, we use WhatsApp a lot. Is it famous here in Czech Republic as well? Okay. So we started getting this message. All the messages you send in this chat and calls are now secured with end-to-end cryptography. And most of people don't know what is cryptography. I've heard people saying, oh, your messages are now encrypted. You must be careful. The government is watching you. And that's not the case. The encryption is there to protect you. So, we have basic principles on how to get information safe. So, we need confidentiality. So, if Alice wants to send Bob a message, the confidentiality will guarantee us that Charles, that is not allowed to read the message, that he can eavesdrop on the message. So it protects against unauthorized access. All the people that should have access to the message can have access, and other people that doesn't have the rights cannot access. We call this confidentiality. Integrity. It serves to ensure that the message has not been changed. So it's very important that the message the receivers get is the same message that was sent by the sender. So we must make sure that the message was not changed during the way to the receiver. And also authenticity. We must make sure that when Bob receives a message, that message was really sent by Alice and not by someone else trying to impersonate Alice. So it verifies the sender's identity. So to break this down in modern crypto, we have now a basic explanation of cryptography algorithms. So we have symmetric key algorithms. Symmetric key means that the same key is used for both encryption and decryption of the message. So we have, on the left side, the clear data. It gets encrypted using only the key, and then we have a cryptogram. This cryptogram can be sent by email, letter, internet, any possible way. And in the other side, the receiver will use the same key and the cryptogram to achieve the clear data. Is that okay, see? Questions? Okay. So, also in symmetric key cryptography, we have two modes, two basic modes of encryption. We have block encryption that gets a message, breaks it into a lot of blocks of the same size and encrypts each block separately. And then we have I have a translation problem right now. Stream ciphers, yes. I speak Portuguese, my native language is, and sometimes you get a twist in the brain. Okay, and stream ciphers, it produces byte by byte. Then you get a stream of bytes that you can shore to your message, so you can encrypt it. So in block ciphers, here we have the plain text, break it into blocks of the same size, and this mode of cipher is called electronic codebook, or ECB mode. This was the first one used, and it has been proved to be not good one to use, because if we try to encrypt an image using ECB, we'll see that the same blocks, they produce the same output. So in an image, you cannot see the original picture, but you can take some information out of it. So we can tell that this is a penguin in the picture in the middle. This picture in the right is if you use any other method other than ECB. Then we have the CBC mode. We break the plain text in blocks of the same size, but then we use an initialization vector. Then this vector gets a shore operation with the plain text, goes through the block cipher encryption with the key, and then it produces a ciphertext. Then this ciphertext is used again as the initialization vector of the next encryption block. So then the same pieces of plain text now will produce different ciphertext blocks because you have a different initialization vector for each block. Okay? And also we have the counter mode. Well, you don't actually use the plain text as an input to the cipher. In this case, you will use a random number plus a counter, and then you upgrade the counter until the length of the message. And then you cipher each block, creating a different output of the encryption for each one. And then you short it with the plain text to get the ciphertext. Nowadays, the most used block mode is known as the GCM, Galois counter mode. And this is an example. Try to make it bigger. Okay. So here we have AES, is the American encryption standard. I'm using CBC mode, importing them from Wolfcrypt ciphers. And then I'll create a cipher with AES, and then I'll have my key, my big secret key, the mode, and an initialization vector. So now I can get the ciphertext out of the cipher, running an encrypt operation, passing my original message. So now I have my ciphertext right here, in this line. And to reverse it back, I can use the same key, so I can use the same cipher. So if I do cipher, decrypt, passing it the ciphertext, I will get my original message back again. I implemented all the ciphers following the path for symmetric ciphers. Zoom out. Okay. So, symmetric key cryptography, it's very fast, but there's one big problem. We need to share the private key. And there are a lot of solutions on how to solve that, but in the end, you will need a safe way to deliver the key to everyone that must have the key. But in the other side, we have the asymmetric key cryptography. They use a pair of keys, a public and a private key. And everybody has its own private key. The private key is only known by its owner. That's why it's called private key. And derived from the private key, you get a public key. And as public key, this key can be shared with everyone. You can make it public. There's no problem of people knowing your public key. Because all the data encrypted with the public key is only possible to decrypt it with the private key. Oops. Yes. So if people want to send me information, they will encrypt this information with my public key. So the only person that could open this cryptogram is me, that have the private key. So here we have confidentiality. If you send a message, only I can open that message. Using my private key, I can take the cryptogram, decrypt it, and get the clear text. The reverse operation, if I use the private key instead for the encryption operation, I will have a sign operation. So I can get any data that I want to sign, and I run it through the signing method with my private key, and I'll get a signature. And everybody that possesses my public key, that is a public key, so everybody has access to it, it's able to verify the signature. So it will feed the verifier with the signature and the public key, and it will return to the clear text, to the clear data or the original message. So we can achieve both confidentiality using the public key to encrypt, or authenticity using the private key to sign some data. Here I have an example. Look, this is the size of the private key compared with the symmetric key. We have a very big key. That's why asymmetric encryption is way more expensive in resources for the machine than symmetric. So we have this big private key here, where I create my private key. And then I have the public key, where I create the public key object. Then I'll get my plain text. Everybody gets Friday off. And I'll cipher it with my public key. So I call here public encrypt plain text. I will get this ciphertext, and this ciphertext is only, sorry. I can open the ciphertext only with the pair key. So I encrypted it with the public key. I can only decrypt it with the private key. So I call private key decrypt the ciphertext, so I get back to the everyone gets Friday off. That was my original message. The signature process, my signature will be my private key signing my plain text. So I'll get my signature down here. And with my public key, I can verify that signature. So I call pub.verify, pass in the signature, and I get back to the original message. The limitation is that the size of the message must be at most close to the size of the key. So we cannot use it for any size of message. There's some limitation. While with symmetric algorithms, we can have more flexibility. Hash functions are like baby steps for hash functions, like basic math. We use a lot of modulos 9 for checking a number. But cryptography safe hash functions, it gets a clear data through a hash function, then you produce a digest of that message. As the digest has a fixed length, we have infinite possibilities of clear message, but we have a finite number of digests. So at some time, we will have collisions. So to be a good hash function, cryptographically good hash function, it has to be easy to calculate, so it has to be fast, and feasible to guess the message from its hash. So you get a hash, you cannot tell what was the original message provided by that hash. Infeasible to modify the message without modifying the hash. So every little change to the original message should produce a big change to the hash. And it should be hard to find two different messages with the same hash. That would be a collision. I have a table to compare hash functions. So we have SHA-1 that is now being deprecated, and the SHA-2 family with SHA-256 and SHA-512. And you can see that the size of the digests is according to the size of the key, size of the hash, and how bigger the hash is, and then it gets harder to get collisions. Now we have available on the internet a lot of databases for MD5. We call it rainbow tables. If you go there, put some word like banana, it will give you the hash for banana. actually the reverse order. If you put the hash for some common word, it will already know which message is there. So it's easy to find the original message from its hash for MD5, so it's no longer safe. So here I have a hash example. I have these hash modules in WolfCrypt, and I have import SHA-256, and I'll create my object with s equals SHA-256, and I'm feeding it with wolf and then crypt. I can break the message. And the digest of my message is this stream of bytes, and I can also have the hex digest method that returns as a hex string. This hash module was also made following the PEP guidelines for hash functions. And from hashes, we have also hashed MACs, or hashed message authentication codes. When you have not only the clear data, the original message, but you also use a key on the function. So you get the message, goes through the HMAC function, and then you provide it with a key. And then the hash, the result of it, will have some kind of authentication because only I know the key and only the receiver also should know the key. So only the owners of the key could produce that hash. So in my HMAC example, I have to initialize my object with a secret key. So I can update my hash with wolf and then crypt, and then I get my digest or my hex digest as I would like to use it. But in all my examples, I use very easy to remember keys or initialization vectors. But one important thing about security encryption is the random numbers. We should always be using random numbers for keys, not using easy words for keys, and not reusing the same keys for messages. So it's a good practice to use random numbers. But then you need a good source of random numbers. Those are called cryptographically safe random number generators. So we have one in WolfCrypt, and it provides both random bytes and random list of bytes, array of bytes. So you can get one by one, or you can get a bunch of random bytes. Yes? I can't hear you from here. She'll get you the microphone.
Okay. Yeah. Who was asking the question? Yeah.
Why don't you use the cryptographically safe generator, which is present in the Python standard library?
Sorry?
For this? In Python standard library, there is a random number
yes.
generator which is cryptographically safe. So why don't you use this? Why there is another one in?
This is just another option. You can also use the random provided by the Python language. But WolfCrypt is a Python wrapper around the C library. So I wanted to export all the functionality from the libraries.
Okay, thank you.
So if you're running in an environment that the random is not available, then you have a new option. At this moment, to install WolfCrypt, I need to both install the C library first, so you can clone the C library from our GitHub repository. Then just autogen, configure it, enable SHA-25012, make and install the library in your machine. And then you can install wolfcrypt using pip. Okay? If anyone knows how to install the C library within the pip, please talk to me later. It's time? I have 5 minutes? That's good. Because the complete documentation is here at wolfssl.github.io/wolfcrypt-python. And as I have 5 minutes, we have a lot of time for questions.
Good. We will have one question. Yeah, good. We have one question on the Slido, but I will give you the mic so you can ask away right away. Yeah? Okay. Is it yours? Okay, so we will get to you. We have enough time. So the first question is, what can you say about smart naming tools, ML-inspired, e.g. the suggest name during coding, or even refactors the wall code for better comprehension?
Smart naming tools.
Oh, but it's okay. So the
Different
next
rule, yeah.
one, why should I use wolfcrypt, e.g. for hashing if there is Python standard library hashing module? Thank you very much.
Okay. Yes, there's hashlib for Python. So wolfcrypt is like when you don't have access to other options, you can use wolfcrypt. As we are, our main focus is for IoT. So if wolfcrypt is present in your platform and hashlib is not present, you can use it. I have one of my students working on a paper to compare speed of wolfcrypt and hashlib, and also different solutions like cryptography, and I think it's PyCrypt, the other one. And also based on the standards, following the PAP guidelines. I'm not sure if the hashlib follows all the guidelines for hash functions. That will be on the result of the paper.
Okay, thank you. And yeah.
Actually, similar question to the one about hashlib, but what's the advantage of wolfcrypt compared to PyCrypto? Is it the speed or something else?
Over PyCrypto, I haven't do the comparison of all of them yet, but mainly we follow the PEP guidelines. We have hardware acceleration options for our C library. So depending on the architecture, you can get better performance using our solution.
I'll be right there.
And what was your primary target architecture?
Sorry?
What was primary target architecture, like ARM or?
Oh, okay, I tested both on my computer and in my Raspberry Pi.
Okay, thanks.
The last question. Okay.
Hi, great talk. I just wanted to ask, can we use wolfcrypt from MicroPython, or have you any experience with that?
I haven't tested in MicroPython yet, but it would be nice to do it.
Yeah,
to test it.
You were talking about IoT, so I think that's perfect match.
I heard about MicroPython back in Python Brazil last October, and it's on my to-do list.
Thank you very much.
Yeah, I was working on a new module. It's the wolfSSL module for wrap our SSL library, so you can use it when you don't have the SSL module available.
Thanks.
Or if you want to get advantage of some features that we have that may speed up the process.
Okay, so thank you very much. Thank you for the questions. Maybe if you will have some more, you can talk to Moises afterwards, after lunch. And yeah, thank you very much for a great speech.
Thanks, Eva.
Thanks. Before all of you will flee to eat something, it's through the doors, of course. We will meet here again at 15:25, so there will be some break for me. But there will be great speeches that will start at almost 2 o'clock in the main hall, so don't miss that. It will be interesting. So talk to you soon. See you soon. Bon appétit.
To už je moc. Jo, takhle. Čím blíž, tím lépe. Aha. Jo. Jo. Mhm. Dobře. Náhlavku bude mít Karla. Co pak? Našla jsi chyby? Jo, hele, tady, to je výborný, tady je vidět. No to je krásný. Na to my z akademie nejsme zvyklí. Karlo, mohla by si vzít tohle? Si tě asi vyfotím. Tak nejhorší, my si to vyměníme, no. Ono se to zapíše, to taky přichytíme.
Hello. Cool. Perfect. So, hello, welcome back after the lunch break. We have a few minutes before the next talk will start. So I will just recap some organizational stuff. So I was mentioning the lightning doors before. We have already 5 slots full, so there are 2 more places, maybe 3. So if you want to speak up, just, yes. These are just for today. Tomorrow will be another paper, and you will be signing up for another paper. Okay? So tomorrow will be another round. So don't worry if you will not be one of those who will speak up today. Tomorrow will be the opportunity again. So the other stuff is that workshops are filling up really quickly. So if you haven't signed up yet, check it out. Please. We fixed the Wi-Fi, so it should be really good to keep up all the questions in Slido this time, and afterwards we will have the Q&A round. And we have the live stream, so maybe for those who are remotely watching us, you can ask the questions on Slido too, so don't hesitate to do so. And if you have some friends who cannot attend, tell them to watch live and ask the questions. And after this talk, we will have a coffee break. So if you didn't have the coffee, that will be the opportunity. And here they are. So, yes.
How long should the lightning talk be?
Sorry?
What's the duration of the lightning talk?
5 minutes. The lightning talks are 5 minutes. Yep. You can ask those things afterwards. So let's start. I hope that we don't have the full house, but it will be okay. So let me welcome the next speakers, Carla and Peter, and they will talk some stuff about the R Shiny and the substitute of Python. So here they are.
Okay.
Cool.
So, good afternoon, all. I'm Carla.
I'm Peter. Hi.
And we are together. We are writing a Twitter account Python tip. We are trying to collect some short Python tricks which fit into 140 characters. And in daily life, I work in Institute of Biotechnology. And Peter's affiliation is a little bit more complicated.
I'm not Peter Symmetric from Kabula, so if anybody come to see that person, I'm sorry, we are 2 Peter Symmetrics. I used to work at the Jackson Laboratory in Maine, United States until 2 weeks ago. I might work at Google if my O1 visa processing will go smooth. And currently I'm working at the Institute of Molecular Genetics at BioSef, which is accidentally the same area as Carla do.
BioSef is a really nice place on the border of Prague. It's the hall in the middle of the picture.
There are now some buildings. This is the old photo.
But Google Maps still has this hall. But we are definitely not computer scientists. I'm a protein crystallographer.
And I work in the mouse genetics, and so we typically work in some interdisciplinary teams. Our colleague might look like that guy. And if you are in the interdisciplinary team, you have 2 possibilities. You can either learn, teach everybody to code in Python or R or something, or the second strategy is that it's everything your task, and every change they come with will end on your desk, and it's your work to do it. And it could be something quite stressful because many people I work with are perfectionists. They want the results to be perfect. So if something is not perfect, they're asking you again and again and again to change your analysis. And the strategy is to to somehow enable them to work with the Python, do some workaround. And we will show it on 4 examples, 4 small applications. We didn't choose anything from about proteins or mouse genetics because we would need a long introduction to that. So we will have really simple thing like this one. This is the simple histogram. It's actually the number of the likes or stars or whatever is now on Twitter on our account. So we are now tweeting for something like 4 months. We have roughly 500 followers. You know, this is the histogram, and one thing you need to tell the program to make the histogram is the number of the bins. And looking at that, it looks, yeah, it should be probably less because it's going up and down. So, but you know, you will decrease it and then the person will ask to increase it again. So the best thing what you can do is to give the user the control about the parameters that are needed to plot the things like that. It's nothing new, actually. When I was reading Steve Jobs' biography, when the Apple designed the Macintosh calculator in 1984, the Steve Jobs was rejecting the version of the calculator again and again after the software engineer got frustrated and basically gave him the ability to design the calculator himself, to select the shades and move the buttons and so on. And this is kind of what we are doing in the projects we are working on. And Carlo will show you the next application.
The next example is similar to histogram, but a little bit more complicated. It's the iris k-means clustering. If you are familiar with machine learning, the iris dataset is quite known for testing purposes in machine learning. And there are 4 different variables. And if I want to give to a user or to my supervisor all the different possibilities or the combination of variables and cluster count, I would have to make many pictures. So the better option is to give him or her a possibility to do it for yourself.
It was originally actually my motivation to start with something like this because I work in the genetics. There are 20,000 genes. It's not so easy to send somebody 20,000 PDF file, each file with analysis with 1 gene. So if you can make it that he selected the genes and get the analysis, it's much better. And so this was some little tweaking of the results, and now we would like to show the other 2 applications that are doing something else. You are trying to give the strength, the power of the Python to the person that is not willing to write a single line of code. So this is the example, something that Carla did, the word cloud. If you can guess what was the source text for the word cloud.
Good.
Yes, Karol Hynek-Mácha. Sorry for not Czech-speaking people in the audience. It's the famous Czech poem, Karol Hynek-Mácha, My. And when you look at that, this is, you know, it's going to some shade of the tree, and the coloring is nice. And if somebody come to you and say, yeah, I want to do the pictures like that, but I don't want Karol Hynek-Mácha, I want, I don't know, Karel Čapek novels, how can you enable the person to do the job like that? And again, you want him to select the book from Karel Čapek, or even select some parameters for the word cloud, or input the whole text. Here is just the book selection, but there could be the text input things where he copied the text and get the word cloud. By the way, all the 4 apps we are discussing are online. If you, it's a long URL, but if you type it into your computer, you can play with it yourself. And the last app we would like to introduce is something that I've got obsessed something like 8 years ago, and those are human faces. Human faces are interesting. We can recognize the known face. It's something like 100 of the milliseconds. There is some successful startup from Mark Zuckerberg that make a lot of money on that. We have something like 42 facial muscles. We are able to do 10,000 facial expressions, roughly 10,000. And we differ significantly in how many faces you can remember. There are people that are famous to remember faces for a long time. They meet you after 5 years and they recognize you. There are people like me that can forget how you look, even if we met 2 days ago. If I will not greet you tomorrow in the streets, it's not because I'm a jerk, it's because I simply don't recognize you. And as that, I sometimes make the group of the faces, looking like the people are similar to each other, trying to remember them that way. And I was asking myself, like, how many type of the faces are there? If I take any person of the audience, would I be able to find, I don't know, famous person, the scientist or the actor that would look alike that person? And 8 years ago, it was the complicated task. Today, you can use any facial API to do the job, and over the weekend to program the applications. You can build a simple application like this. You can try this on your own on this web page, but please don't do it now and all in the same time, because it's small Amazon EC2 machine is probably crashed down if everybody tried. But if I want to see if me or someone else, someone from you looks like some scientist or actor or actress, or there is another group of people we don't want to talk here now because of the PyCon codex. We can simply upload the picture, the photo to our Shiny app. And for example, on this slide, I wanted to see if Petr is similar, if he looks like another scientist, and I think it's a pretty good match. Even the name is the same, Petr or Peter. So if you want to try in the evening, it's openly available. And there's a little dirty secret I should tell you, and that is that up to now, all the code, all those 4 applications we have presented here was not written in Python. They were actually written in R Shiny, so we are now on PyCon talking for 10 or more minutes now about R, which we do apologize, but as you can guess from my t-shirt, I'm originally coming from this era, and our interest at the beginning was, okay, Python is much more powerful language than R. Could we find something like the Shiny in the Python world? And so first, what the Shiny is. The Shiny is very little web application framework where basically in the most basic applications you provide 2 files, UIR, when you select how the page look like. This is the example for the iris clustering. So even if you never see R or Python, you can guess, what could it be doing? We have there something like 3 inputs. In first 2, we are selecting the variables. In the last one, we are selecting the number of the clusters. And we have the output that is doing the plot. And in the second file, the server R, you basically describe how to get the output from the input. And behind the scene, the Shiny is building something that is called reactivity graph. That is basically telling, okay, if you change the input, how to propagate this change to get the output. It's something, this is very embarrassing slides, but it's something like the Microsoft Excel. If you have the spreadsheet and you have the calculation in the spreadsheet, if you change one cell, the change is propagated, and the Excel very similar graph behind that as the Shiny does. So we were thinking like, what is in the Python word that is similar to Shiny, because we feel that Shiny is We love Shiny in R. And when we have been looking for something like 6 months ago, we have found this tweet, and it's from the Wes McKinney. It's the creator of the Pandas. We have here Pandas in the morning. And he's basically saying, okay, we don't have Shiny-alike software for Python, and that's a problem. The tweet is 2 years old, so we were thinking, okay, maybe, somebody created something in those 2 years. And Carla will tell you what she found.
Yeah. So I was Googling what to use in Python instead of R, Shiny, and the Google gave me these five possibilities. There are some simple visualization libraries like Bokeh and Dash. There are more versatile web frameworks like Flask, and I was trying to recreate all the Shiny apps we have just shown you in these five frameworks, and all the code is on my GitHub, and I will give you a link later. All these frameworks has its own pros and its cons, and I will shortly show you or talk about all of these frameworks. So first one is Flask. I think many of you will be familiar with Flask. It's pretty versatile web framework. There are many extensions and broad community around Flask. So almost everything is possible to build with Flask, and we were able to reproduce all the five web apps in Flask. But I think it's for this case, for dealing with data and showing data to someone, it's a little bit of overkill. So I don't want to build a car like this just for driving to work. Then there's Spire, and I think Spire is almost perfect for the case or for dealing with data showing and giving users possibility to change parameters, and it's almost that what I wanted, but it still has some cons. It doesn't support sessions, so if you have more users connecting to your web app in the same time, it can cause problems. So Spire is almost perfect, but not really what I wanted to see. Then there is Dash, which was built mainly for building dashboards for plotly made plots, and that's exactly what it does. It cannot do more than this. It's very useful for showing and fiddling around plotly plots, but another problem with Dash is that the current version of Dash is no longer maintained, and the new version should be up was announced to be up during May, but still we are waiting. So we cannot be sure what the new version of Dash will do. Then there's Bokeh, which is mainly a visualization library. So it allows you to add some interactivity to Bokeh-made plots, but again that's all what it does. So no file uploading, no data wrangling or so. And the last one is bowtie, and according to Internet and Stack Overflow, it should be a really powerful library. It interacts with some JavaScript libraries, and it should allow you to build just really shiny-like apps. But I think that
you can deploy to Heroku server, which for me was something that I was really interested. The problem was that we never succeeded to do so.
Yeah, it's I think it's user-friendly, like something like this.
So it could change. The creator is very responsive, probably a very nice person. Maybe if you are more advanced with the web development, you can have different experience than we had. But we are sorry. This is exactly. On my computer, I was never able to make it working.
I was able to make it working on my computer, but not on the web server.
So it's kind of And you know, our original motivation why we were going through those framework was to collect the experiences and then make something of our own, which might sound quite challenging if you are still quite new to Python, but we got inspired from Andrew Ng, the Coursera founder, that he told us that you should not be fully qualified to the projects you are starting. It's better to start with something new and learn on the way. Unfortunately, somewhere in the middle, we felt more like this dog, and we slightly stuck. We definitely learn a lot about Shiny. I mean, I've never fully appreciated what's behind, and not only Shiny, but for example, the Flask, what this web applications is taking care of, and that's you really discover if you try to start yourself. Try to do it yourself. So we have some small framework that is built on the CherryPy, which is the same web server that the Spire uses, and we have some technology to spread the information through the reactivity graph in the same way as Shiny, or slightly different way, but both are using WebSockets, which for me was the new thing. And we are using the implementation in the WS4 Pi module that kind of works nice with the Shiny. So we have some pages that are working, but it's currently under development. We don't feel yet comfortable to really share it. If you are looking for some open source project, or if you are looking for some diploma thesis, we are very open for the collaboration if somebody would like to join. And that's probably
So we are really waiting for.
So this is our Twitter account. We are in a constant search for the Python tip. If you have, something that you can fit into 140 characters, let us know. There is a form. We'll publish that. The slides can be downloaded from here. And if you are going yourself to select the framework, I would highly recommend to go across the codes. And we really tried those 4 applications, or Carla tried to be more humble, to implement every of them, and you can, find your favorite one. Thank you very much.
Thank you.
Okay, perfect. Thank you for the talk. We have one question for you at the moment. Maybe somebody in the audience will want to ask afterwards. So, if you could read with me, I will read it, but yeah. How do you share and maintain R Shiny apps within your group? Do you have an R server? I think
that's an excellent question, because that's, I believe, the way how the R Studio is currently making a lot of money, because I don't know how many of you work with the R Studio, but you can deploy the Shiny application just by clicking the button, and some magic happened, the application is packed up, sent to the RStudio server, and it become alive, which is absolutely awesome. The only problem is that if you're a scientist like me, it's pretty costly. They will give you some 10 hours a month, and it run out as nothing. So the other way is to run your own Shiny server, and it's not so hard. If you want to ask for the advice, ask me. What I'm actually doing, how this Shiny is working on, I'm running the small Amazon EC2 virtual machine. You can use Google Cloud, DigitalOcean, if you prefer these clouds. And because the administration and installation is not my strong, I'm not so strong in that, so I'm using the Docker. And then you can run your Shiny server with one line that will start the Docker and keep the server running. So it's as easy as that. Other thing is that for many person are using Shiny just on their computer or the computer of the collaborator. They really don't need to spread it with the whole world. And the very last possibility that I don't have personal experience is something called RStudio Connect. It's the recent thing that was introduced, I believe, in January. And with that way, you have the R server at your organization, and the RStudio, again, with the one click, you're able to deploy it on the R server that is running on your organization. So this is it, and I have seen the second question there.
Yep. There.
Thank you for your talk. I want to know, you mentioned that one of the drawbacks of using Bokeh was that it's static, or you can't upload things like images or data to the Bokeh application. So I want to know, do you think if it's possible to use Django along with Bokeh to try and get something more interactive, or have you tried this and failed, or does it not work, or?
Yeah, I quite didn't want to use Django with Bokeh because Django is quite a big framework, and I don't want to learn all the Django things to deploy a simple app. So Flask is more easy for me to do this, for example.
Question, apart from this particular example, do you think there's any other part in which Python is lacking compared to R? Or where you wish that Python... I'm sorry.
That's an excellent question, because we were looking for that as well. And I think one more thing is the Hadleyverse. So it's called the Hadleyverse, or Tidyverse is the new name. And it's basically the collection of the packages around the developer Hadley-Wickham. And I would say the most, what I'm missing when I'm in Python world is the ggplot2, which is the graphic library to do the plots and graphs using grammar of graphics. And the thing is, you now have some ggplot clone or import. I think even 2 groups are trying to do so, but it's not comparable. So even if I'm working with, for example, Python notebook, what I'm doing, and I don't know, maybe all of you know it, but you can use other languages in Python notebook. So if you know some good R trick, you can use the R magic in Python notebook to get a graph. It's harder with the Shiny when I kind of don't know how to, use Shiny in the Python world. It's probably would not work too good together, or at least I have never seen that. But yeah, if I should pick one thing, I would say ggplot2 is what I'm missing the most.
Okay, here's one.
Hi. Can you tell us a bit more about the k-means algorithm you used below? The k-means in the iris? Did you run it on GPUs, or how does it work when you have a web app and you want to optimize for the And yeah.
No, sorry, this was really simple k-means. This is the IRIS data set. I don't know how many you know what the IRIS data set is. It's dating back to R.A. Fisher, so 30s? Do anybody know in the audience when the R.A. Fisher works? So the data set has, do anybody know it from the head? Something like 100 of the lines. You don't need the GPUs for the 100 of the lines, but yeah, I actually have used the Shiny with the GPU behind, and it's challenging. For me, the biggest problem is if somebody goes wrong, to detect, on which level it went wrong. Could be sometimes, yeah. But all of these applications are simple, are running in a short time. If it would not be the case, like if I need to monitor some big k-means clustering job, I don't know. I'm not sure that I would like to run that as interactive Shiny app, but it could be my problem. I have no good answer for that. Carla, do you want to?
No.
No. Okay.
Another question?
But how would you approach it? Like, what engine would you use? Like, what software would you first calculate everything, all the 20 pairs, and then save?
Actually, now I'm thinking about it. I'm doing right that one. Like, sorry, it's what I'm doing in my daily job is the QTL mapping, which basically means you have some trait you are interested in, like the body weight, and you are looking like which part of the genome, in my case the mouse genome, not the human one, is responsible for that. And this is something that takes, I don't know, several minutes for one gene. So if you want to do that with the Shiny, you cannot, or it's hard to do it on the fly. And what I'm doing is I take my 20,000 and on the cluster, I do the analysis for each of them. I save the results to the file, and then when the user asks for the given gene, I load the results and just fetch him to the results. So it could be in the database, or the very simple thing is it could be on your disk and sitting it there. So we can discuss more over the break, but I would say there would be more than one good answer for that. Okay.
But what do you do if the data changes, if it's like online streaming?
Yeah. That's the advantage of the mouse genetics, or the mice are dead and they will definitely not change.
So we will have one more question, and then we will have the coffee break. So.
Okay, hello. I would like to ask, do you use some libraries in the genetics, for example, BioPython, in the research, or do you use some?
Yeah, I really don't use. I don't do genetics, but I use BioPython, and now there's a nice library called BioPandas. To work with protein structure files. It actually read PDB, protein database file into Pandas data frame and allow some further work with that. But with genetics, maybe
For me, I've learned to use bioconductor, so that's the R word set of packages. And for me, still, the bioconductor, somebody asked about the ggplot, but the bioconductor is another thing that it's still worth to use R if you are doing the microarrays or some RNA-seq. But the world is changing. I mean, every year, new and new Python modules appear and the setting up. So, but the current thing is that still there are the analyses that you need to use R and not Python. At least I believe so.
Perfect. Thank you for all the questions. It was really nice, and thank you for the answers. So, if there are any more questions left, you can catch up Carla and Peter afterwards during the coffee break. So now we will finish, and we will meet here in 30 minutes. So I hope that you will look forward to another speaker, who is Peter. Another Peter, not you, who will tell us something about how to create a new program, new subject that will be taught at the university. So it will be really, really interesting. So yeah, see you all later, and if not, enjoy the main hall talk. So yeah, goodbye for now, and thank you very much.
Jdem na to.
Jdem na to. Tam je ještě pár minut, teď se dosypu, oni už jsou teďka takový, mám pocit, trošičku vláčnější.
Či úplně náhodou nebude z toho zvuk?
Ne, úplně v pohodě. Když tak můžeš na mě třeba tak v půli, jen tak jako dát nějaký signál, že tak jsem jako v půli.
Já ti stoupnu, takže můžu? Výborně. Hello. Welcome back. I hope that all of you got some coffee. There is not that big a queue as it was before, or a beer. Yeah, cheers. I'm looking forward to my first beer today. It will be in 2 hours. Yay! Okay, so the next thing up in theater, it will be not the clean code in Python. It will be another subject by Peter. It will be, he will be telling us something about how was it to create a new subject that will be taught at university, at Masarykova University in Brno, I think, yeah. Yeah, well, let's welcome Peter and let's listen to what he's have to say, so.
Okay, thank you. Okay, thank you very much. It's great to be here at this conference. I would like to first thank to the organizers for making this wonderful event happen. And I will start. My contribution is called Python for Physicists, and I'm not going to talk about any deep or generalized ideas about how to use Python, especially when you're a physicist, a professional. Python for Physicists, as you can maybe deduce from the first link, which is over there, is a subject we created for this semester that has just ended 2 or 3 weeks back. It was created at Masaryk University, Muni, at Faculty of Science, and this 4, the number 4 means that it was primarily devoted to students of 2nd year of university studies. All of our material are also hosted at GitHub. Try to click on it, it won't work. It is, yeah, so this is GitHub pages for that. So you can take a look later on that. All lectures are hosted there. No. Back to my presentation. And the reason why you see so many names is that all those people have been somehow involved into preparation or teaching this course. Let me quickly name them. Filip Hroch, he was our, let's say, spiritual leader. Petr Klenovský, Filip Minc, Adam Obrusník, Petr Sinek, Jan Voráč, Jiří Polcar, Jakub Wagner, and lastly my name, Petr Zikán. I'm glad that so many people came here, but are you sure you want to be here? Because this is going to be at least a bit about physics, so I was expecting more something like 12.5 people here and the rest sitting in the other room. So you can run away right now if you want. No one? Okay. And something about me. I'm a PhD student at Masaryk University. I'm studying plasma physics, trying to finish my PhD for almost 4 years or something like that, but that's not that important. And so this is overview. One more thing, there will be few code snippets, and the font in those snippets is quite small, so I'm afraid you won't be able to see it from the back of the room. I'm sorry about that. I tried to make the font a bit larger, but I somehow failed. I'm not, CSS man or HTML or something like that. So overview of my talk is I will first tell you something about our approach to the course. This is going to be the boring stuff, but I will try to make it quickly. And in the rest time, I will tell you, I will show you a few examples we created for students and some typical problems you can encounter in physics, and of course using Python. So this will include, we will start with linear regression, then we will trace through few particles through electromagnetic fields, do some Fourier analysis of plasma response, and as a grand finale, we will briefly touch machine learning with scikit. Okay, so our approach was as follows. Since a standard course on Python was already present, or is still present at the university, we wanted to offer a bit different course that would be mainly focused on how physicists use Python, and therefore we had these 3 cornerstones. It was NumPy, Pandas, and SciPy libraries. We also wanted to minimize the amount of time spent with theory, and our wish was to explain fundamentals of the language as we go, which is somehow tricky, as we saw after that. We also wanted to at least try to involve students into programming during lectures as much as possible, and therefore we chose that these lectures take place in a computer room, so that everyone had access to a computer. We also decided to use Jupyter notebooks exclusively, because most of us, or at least half of us, agree that this is a great way how you can do some data processing and number crouching using Python. It's also a great way how you can visualize your results really quickly, and it's also, at least from my point of view, quite friendly to students. And that's it. We also use these checkpoints and quizzes. What does it mean? Usually the lecturer's notebook, Jupyter notebook, was projected onto the wall, and students were following us by retyping our commands, and once in a while, let's say every 10 or 15 minutes, we make sure that everybody is up to date, that his Python environment is the same as ours. Therefore, there was one lecturer and at least one, let's call him helper, he was online help to the students. We also use these quizzes, which means that 2 or 3 times per lecture we made this quiz, and students were supposed to slightly modify the code we provided to them, or do some change or something like that. This is, at least from my point of view, quite important, because students need somehow to play with the Python, because if you want to learn programming, you have to program well. So this was it. this was the boring stuff, and hopefully this will be something more fun. This was first lecture, and there was quite an intensive debate among us how to start it, because we wanted to offer almost immediately something that could be of any usage to students, and therefore we decided to start with linear regression, which is a very typical problem in physics, and students will encounter this problem very soon during their studies. So the problem was as follows. Suppose we have some data stored in a CSV file. The CSV file is also quite common to Excel users and students, especially in the first or second year of studies. They use Excel quite often and quite intensively. So I'm really sorry if you don't see from the back, but hopefully this is mainly where's my mouse? There. This is the content of a file. We have 3 columns here. One, let's call it T, which is a parameter 15 till 21, and then we have 2 columns. Let's call it A and B, and these were somehow measured during lab or whatever, yeah, this is what I said, and we usually need to do some data processing before our analysis, and this time we decided just to simply multiply these 2 columns and to obtain a column, let's call it C, which was multiplication of A and B. And the value of interest was the slope of the curve as a dependent on the parameter T. It might seem quite hard, but it's really easy, as you will see in a moment. We decided to start with Pandas, which is maybe a bit it's not that traditional. Suppose imagine you don't have any previous experience with a language, and first data structure you see is Pandas data frame, which is usually considered as, let's say, advanced data structure. But again, it maps so perfectly to Excel spreadsheets that students usually don't have any problems with that, because if you just import Pandas, which you can say is a magical command, then Pandas has function read CSV, and if you provided the file name, you will end up with, let's call the variable data. You probably not be able to come up with better name, as we previously heard. And if you print this data, you will obtain this HTML table, which is just perfect. Students are able to follow you. There's nothing, magical, although there is. So we have loaded our data. Multiplication using Pandas is also very easy. If you want to add a column C, over here, you just type data A multiplied by data B, and magically column C will appear in your data, which is very easy. It's basically one-liner. So if you move on, you typically want to take a look at the data. It's also very easy using Python. If you import matplotlib.pyplot, and this magic line tells Jupyter that we want to see the output of the plotting command directly into Jupyter. Then with another one-liner, matplotlib.pyplot, first argument is our x-axis data, t column. The second parameter is our c column, which will appear in y-axis, and this O tells that we want to use points for data representation. Now, the linear regression, which is the tricky part of this approach, but you can tell to the students that this algorithm is already implemented, of course, in SciPy environment, and they need to just import SciPy optimize, and there is this curve fit function, and if you attack it with a question mark, it will offer you online help, which is also quite important to tell the students that they are not alone, and that they can get some online help really soon. And this is just copied from the online help. You see SciPy optimars curve fit takes 3 arguments, f, which is described here, x data and y data, and the description is use nonlinear least squares to fit a function f to data, which is exactly what we need. F should be callable, and it is the model function, and it must take the independent variable as the first argument and the parameters to fit as separate remaining arguments. Then it will take x data, y data, and it will return 2 things, p opt, which is optimal values for the parameters so that the sum of square blah 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 squared error is minimized. This is what we are sought after, and pcoff, which is covariant matrix, is not that important here. So if you do it, it's again 3 lines of code. You first define your function f, which takes x as a first argument, c0 and c1, and it models our line c0 times x plus c1. And if you provide this function f as a first argument to this curve fit, then provide data t and data c, it will give you back popt and pcoff. And if you print popt, you will see 2 numbers. One, this is the parameter c0, which is 0.0627 approximately, and the second one is 70 point something. So the first parameter is the slope of the curve, and the second one is the shift at y-axis. If you want to see our fitted line in a graph, it's also very easy. You just need to call that matplotlib plot function twice. First with the measurement data, and second time with our modeled line. You see we used our function f, providing it data t and our 2 estimated coefficients. It will give us back y, and we will use later for the plotting. Well, the graphic is still a bit ugly, and you can do much better with pyplotlib. You just need to do some magic part, like enlarging fonts, enlarging label size, title size, font size, make the lines a bit more wider, marker size, fonts, and so on and so on. And if you do this, you will end up with much better plot. You can use LaTeX, as you see. You can do pretty much anything what you come up with. So this was the very first lecture, and it went quite well. It's quite nice problem, and it was nice start of the course, at least from our point of view. Second lecture was devoted to installing Python environments to students' machines so that they can work on their own laptops during the courses. And the remaining time we provided a small quiz which was focused on using online resources, mainly Google, Stack Overflow, and other great Python documentation which you can find on the internet. These 2 lectures, third and fourth, was the most, let's say, theoretical ones. And we introduced so many concepts during these 2 lectures, like Python lists, Python arrays, basic plotting with matplotlib, how to define functions, how to use them, how to use for loops. Philip Hroch used for loops for finding a resolution of a telescope using bisection method, but I don't have this example here. And on lecture 4, I focused what is the difference between alias and the actual value, how you can manipulate strings, what is the difference between mutable and immutable data structure, what are data types and conversions, what is working with files, and so on. This was really tough. It was really tough, and I'm sorry to all students. I will try to do a bit better next year. And so after these 2 really tough lectures, we thought that it's time to make a step back and to have some fun. And this fun was with Adam Obrusník, and it was the particle tracing in electromagnetic fields. But it is turned out what is fun for teachers doesn't have to necessarily be fun for students, because the problem is to solve this second-order differential equation, which comes very natural to me because I'm dealing with this stuff for several years, but students, well, they didn't. So it wasn't that easy. But basically the problem was, if you have a particle, then its state is fully described by 6 numbers. You can call it position, x, y, z, and its velocity, vx, vy, vz. And this beast is describing the temporal evolution of the particle trajectory, giving some initial values. Basically, this is second derivative of particle position, which people call also acceleration. It's not that hard, but you usually don't ask how fast is your car able to change rate of position, but you just call it acceleration. This is electric field. This is particle velocity, and this is magnetic field. This V can be represented as a vector of these 3 values, and this R can be represented as a vector of these 3 values. But if you want to use some standardized solver, which is part of SciPy library, you have to convert this equation, this single vector equation of this single vector equation into system of 6 differential equations. This time there are only first derivatives of variables. You can see these 3 are fairly trivial. We're just saying that the time change rate of position is its velocity. It is a trick how to make your system standardized. Therefore, because solvers usually expect that on left-hand side of your equations you have only derivative of your variables, and you need to provide some function which will give them back the right sides of the equation. So in this time, velocity at the moment, and this is the right-hand side you see here, but just written down into its component. This is vector product. I hope you're at least a bit familiar with it. And here it is written down into single components. So this is how the function look like. This is RHS function, which takes time as a first argument, and Q, which is a vector of 6 variables, x, y, z, vx, vy, vz. And it will give back, you see dvx dt, it's just these 3 lines are basically those 3 lines, and this one line is these 3 equations. You also need to know particle charge and particle mass. In this time it is electron, typical electron, and it will return the time derivative, basically the right-hand side, and the solver will take this function. And yes, of course, we have used E and B, which are our fields, and in this time they are quite easy. It's a homogeneous electric field in Z direction and homogeneous magnetic field in also in Z direction. And this is how you can set up the solver. You will import ODE from SciPy integrate, and you will call this ODE function with our previously defined RHS function. It will give you R object, which you can use to integrate and to evolve in the time. You need to set up some initial time, which is this time 0, initial velocity, initial position, which are these 3 numbers. So the particle is located in the origin, and 3 numbers which represents velocity. So initial velocity, so the particle has initially only velocity in y direction, and the time step, which is this time in this case 5 nanoseconds. And if you run this while loop, it will integrate until you reach your final time, which in this case was 60 milliseconds or whatever, 60 microseconds. Yeah, and if you plot it, you will end up with something like that. Sorry, the picture is quite ugly, but the matplotlib is not well suited for 3D plots. This is Z direction, and as you can see, the particle is making circular motion along the field, and it's also accelerating downwards, making this spiral. So this was the most funniest thing of our course, which wasn't that much funny at all. But Adam then changed these two electric and magnetic fields and make it much more complicated, and we showed to students how a so-called magnetic mirror can work, which means the particle can be reflected back by a strong gradient of magnetic field, and we showed them how they can set up simulation like that. Yes. What is the time? Půlka, paráda. Okay, perfect. So we can make slide change, slide pause. Are you still with me, or?
Can I have a really quick question?
Of course.
So this is analytic solution?
It is not analytic solution, it's numerical solution, basically.
But don't you usually do like particle tracking, like common filters or some sort of machine learning, like putting like trajectory for the points, like like insert?
Mm-hmm. No, this is not a fitting or analytical solution. You have you know where particle is at the very first moment, and you know its direction, and you just integrate this. Just numerically integrate this equation to evolve into next time, and you trace the particle as it moves in electric or magnetic fields.
So it's easier than fitting.
It's a different approach. If you need something to fit, you need to have some data. This time you don't need anything. You just say, okay, my virtual particle is in the center of coordinate system. I know electric and magnetic field. I know its initial velocity, and then you can move forward in time to get other values of particle position and velocities.
But can you use fitting on this problem or not?
You can, but I can't think of any useful example. Why would you do that? Maybe we can.
That would mean it's like just some problem, right?
It's a different problem. Basically, we can discuss it later if you want to. Okay, but feel free to ask me anytime if you're interested. So, yeah, lecture 6. This was the most let's say demanding. We had this hypothesis of Pavel Dvořák, which is a really clever guy. He's our colleague. He's work at the university, and he said us this very complicated 2 or 3 sentences. He said that plasma response right after its ignition should be pure sinusoidal signal. On the other hand, the plasma response in the steady state will have, thanks to its nonlinear nature, much more complicated time dependence. Fourier spectra of the beginning of the pulse will therefore consist only from one frequency. On the other hand, in the steady state, there will be many higher harmonics of the driving frequency. This is really complicated, don't you say? But I will tell you what does it mean. Usually, imagine you have 2 plates, 2 metal plates. Let's call it electrodes. One is grounded, and on the second one, we apply some voltage. This time, radio frequency voltage, which means that the signal, the voltage we are applying to the other electrode is a sinus wave, and it changes with 13.56 megahertz. So it's changing really fast. The sign of the voltage, sign of the voltage. It's just switching voltage many times per second. And what will happen under circumstances, you can create plasma in between those two plates, and the plasma will somehow react to the applied voltage. It will also oscillate, or what we call space potential of plasma is somehow connected to the driving voltage and will respond somehow. And what Pavel says, that right after its ignition, it will be the same sinusoidal signal as is the driving voltage. On the other hand, in steady state, it will be something much more complicated. And he also provided us with data from his measurements. So he gave us some oscilloscopes measurement of plasma voltage, and we provided students with these files with some weird TRC type of file, which is produced by the oscilloscope, whatever it is. And we provided students with this simple module, read TRC, which they can use to simply crunch the numbers from this binary format into three variables, T, U, and this is some dictionary info. So T is time, and U is the voltage response of the plasma. And if the students plotted it, they see something like this. So this is one pulse, basically, and this is the very beginning. Do you see the mouse cursor, at least a bit? So this is the very beginning of the pulse. This is what Pavel was talking about, and this is the end of the pulse, where the steady state was certainly reached. And if you plot the very beginning of this pulse, let's say if we really zoom into the beginning of this pulse, you will end up with something like this. So this curve is zoomed in to very beginning of this pulse. On the other hand, if you zoom in the very end of the pulse, you will get something like this. So you can maybe see that this is something that resembles sinus quite well. On the other hand, this is no longer sinus at all. And Pavel also told us how we should approach. We should apply Fourier analysis to this time series to obtain what we call Fourier spectra. And luckily, in SciPy signal, you have this very handy function. It's called periodogram, whatever it is pronunciation. And if you provide it with the voltage, this is voltage at the start. This is basically this time series, and this U end is this series. You will end up with a picture like that. So the blue curve is the Fourier spectra of the former time series. On the other hand, this orange curve is the Fourier spectra of the time series at the very end of the pulse. I made also a perfect bokeh plot of this, and if I try to zoom in somehow. And if we zoom in, you see that there is only one peak at this Fourier spectra, which means that the time series consists only from one sinus wave with this frequency. And if we will be, we'll be able to zoom even a bit closer, we will see, maybe that is something like 13.5 megahertz, which is exactly the driving voltage of the plasma. On the other hand, the second, let's zoom in. The second curve has much more complicated dependence, which in this case means that the time series of the plasma response at the end of the pulse was the sum of all these sinus wave with these frequencies. Each peak corresponds to one sinus wave with one frequency, and the height of the peak corresponds to its amplitude. So Pavel was right, and we were able to verify his hypothesis. So this was lecture 6, basically. It's also quite nice, according to my point of view, because this is very typical for physics. You usually have some hypothesis, you need to do some measurement, you need to take a look at the data, get somehow some feeling about it, and then do the right analysis to test your hypothesis. So, yeah, lecture 7. This was meant as introduction to modules and classes. And as it turns out, this was quite a hard problem because, to get used to objectual thinking isn't a matter of, 2 or 3 hours. So we were thinking to skip this part. However, Python is object language, so it would be at least a bit cheating, at least from our point of view. So we decided to do this quick show, although it's not a perfect example of a class. And it was the modification of the first lecture. We created this object. We read those 3 columns from a CSV file, save it as self-data, then create this column C, define function f, and call this curve fit with it, giving popt, which is exactly the same as we obtained at the first lesson. And then we show inheritance in this silly way. We just inherited from linrec and override the function f to have a bit different function example. We just put this -3 here, therefore this is 100, and there was 70, which is the difference. But we are still struggling with this issue, so maybe if you know about some good way how to introduce classes and objects to students, I might be interested, so you can talk to me later if you know about something. And we are getting to an end, I suppose. So don't be worried. Lecture 8 was about rotational spectra of nitrogen, but I wasn't at that lecture, and it seems that the material on GitHub is somehow incomplete, so I will skip it. 9th lecture was devoted to linear algebra using Python and especially NumPy. We used all those typical shape, size, trace, diag functions, how to use inversion of matrix, how to compute eigenvalues, eigenvectors, and of course how to solve system of linear equations. And last lecture was some gently introduction to machine learning. This was invited lecture of Jiří Polcar, it's my colleague from a company I work for, and he showed some typical workflow patterns using scikit-learn, especially fit, transfer, and predict workflow. And of course, we took advantage of Iris dataset, and we did some, in this case, principal component analysis, where previously 4-dimensional data we project onto only 2 dimensions and plot it and color it according to type of iris flower. And this is it. Conclusion, I think, or at least we all think that, involving real-world examples can help really much to students with first struggles with programming. We need to rethink those 2 theoretical lectures, 3 and 4, and try to offer some more gentle introduction to Python to the students, and we definitely need to do a bit better with classes. So this was from my side, and thank you very much for your attention. If you have any questions, just ask me. I'll try to answer.
Okay, perfect. Thank you, Peter. It was really, really good talk. And we definitely have some questions from the audience, so let's skip to Slido. So the first one, how much physics knowledge do you require for the course? So how much of physics you need to know to be able to contain the data, the information?
I think you need at least something, at least basics of mechanics and maybe electromagnetics, but it's not that important, and you should be able to do even without any previous knowledge if you're able to learn physics at least a bit during the course.
Okay. Was that sufficient answer? Yeah. Okay. So the other one is there going to be a MOOC version of this course?
No, there's one above.
Oh, I'm sorry. Oh, it disappeared. So we will get to both of them. So
Okay.
we can start with the second one and then go to the first one.
I'm not sure if I know what is MOOC.
Yeah, me neither. So if you don't, then
Something like Coursera or edX. We are not. Okay, whatever. So something similar to Coursera. We're not there yet. We are just at the very beginning. So maybe in the future, but we are all exhausted and we need some time to rest. And maybe next year we can come up with something, a bit more improved, but especially not any soon.
okay, thank you. So the first one, what is the motivation behind choosing Pandas and Scikit over the EG H2O? Pandas has troubles with big data. How would you deal with computing on clusters?
We deal very easily. We don't deal with it at all because we are focused on the very simple data analysis where your data can fit perfectly on your memory of your computer. This is really introductory course, so we don't deal with Spark or these frameworks at all.
But isn't that something that you guys will deal with when you have to start with grids all over the world to separate the jobs?
Yeah, but usually people in first or second year at university don't do this. So we try to focus on what's important for the students on the beginning of their study. And this is not, big data processing. It's usually 10 lines in their file, which they obtain during some subject in lab or something like that. So there's no need, at least from at this introductory course, for any big data processing.
Okay.
Is it okay?
But still, why Pandas and Scikit has to do together?
It's pure Python. Pandas is, so great. It maps perfectly for Excel spreadsheets, which is, at least from my point of view, quite important. So that students are quite familiar with the structure already. And Scikit is just, that was just the machine learning isn't usually done much on physics, on physics. So it was just, just simple introduction just to tell students that there is something like machine learning in the world.
Yeah, but they have the same stuff in
Yes, you can choose whatever you think.
I don't want to intervene, but we have one last question, really quick one. Is the presentation available somewhere? Is it online? Or?
It is. I provide at the very first slide. It's hosted on GitHub. If you change to my
please can we change
back.
to the presentation again from the Slido?
Perfect. The second link is to my GitHub account, and I will post this lecture in, I don't know, 10 or 20 minutes right after this talk ends. So you can find it over there. My account is Ziki5, and the repository is named Python Pro Physiky. You can Google it, GitHub Python Pro Physiky, and it will be there in half an hour or something like that.
Okay, we have one more question, but I will ask you to ask afterwards because we need to change to the next speaker. So thank you, Peter. Thank you very much.
Thanks.
It was cool. Perfect. So the next speaker will be Mariano, and he'll be talking about some clean code that will be well maintained. So I'm really looking forward to that, and I hope that you do too. So in 5 minutes we will start, and yeah, see you soon. Hello, hello. Perfect. So we have a few minutes before Mariano will be ready for the talk. And before that, I would like to ask you if anyone wants to share some lightning talk. There are still some spots available, so don't hesitate. After this talk, there will be the lightning talks round in the main hall, so we will all move over there and we will listen to other people, what they have to say. It will be 5 minutes, really quick talks on any topic they choose or you choose. So if you're interested in standing in front of the audience, that's your moment. And yep, it seems that everything is ready and we have a full house again. So cool. I would like to introduce you Mariano, and he will be talking about maintainable code. So here's Mariano.
Okay, can you hear me? Thank you. Okay, hello everybody. Welcome to Clean Code in Python. Let's talk about quality code in our favorite programming language. My name is Mariano Nasha. I will upload in the presentation, and the idea is to explore some things. First, if you try to define what is clean code, you'll find that there's not a sole definition of clean code, and instead you will find probably many definitions as developers available out there of authors. But among all of them, I'll pick this one by Ward Cunningham, who says that clean code is one in which every function does pretty much what you would expect as you read through it, and that you can call it beautiful code when it also makes it look like a language was made for the problem. And that last sentence is the reason why I think this is a more accurate definition, because this is what we call Pythonic code, or idiomatic code in Python. So throughout the rest of the slide, we'll see what is Pythonic code and how to achieve this, and most importantly, what features that Python provide in order to have maintainable code. So if you had to think or to say one thing about clean code, you can say that clean code is focused. It does one thing and does it well. And that thing that it's doing should be pretty much what you would expect when you read the code, meaning that you shouldn't be guessing or reverse engineering the code. And this is important for many reasons, because arguably the quality of the code will determine the quality of the software. We know there's a string correlation between a code that is complicated, and as a result, the software, the product, has a lot of bugs, and it's harder to maintain. Whereas the opposite is true. If you have a maintenance code base, it's less likely or had severe bugs, and even if they are there, they'll be easier to spot and correct. So basically, the degree to which you can read the code and actually understand what it's doing is actually highly important. We all know from the sense of Python that readability counts, which makes perfect sense, because if you think about it, as developers, we spend much more time reading code than actually writing code. Whenever we want to make a change or add a new feature, we first have to read all the surroundings of the code we're going to modify or extend, and for that we need a code that we actually can maintain. So this is somehow related to agile development in the terms that if you want to actually ship changes or features effectively, we need a code base that we actually can work with, which is also related to the fact that the code is a part of the design. Back in the old days, we used to think that there were some design documents or models, and from that we derived the code. But nowadays, we know like the code is part of the design. The code is just, and we have to treat it as a design document or as a design model, such as if we were a class diagram, etc. And for that, we need a code that we can read and understand. On the other hand, we have some things that are exactly the opposite to what we want. For example, code that is not intention revealing, and that is not expressive enough, that is complex or obfuscated. Code that is duplicated is actually probably the worst thing we can have, because all of these are actually, in the end, forms of technical debt. And technical debt is something that jeopardizes the project, but it's an underlying problem, and it is much difficult to spot or identify. So we want to actually get rid or have as less technical debt as possible. And the first idea I'd like to introduce is the concept of meaning, and by this I mean how expressive or how able the code is telling us what it's doing. So imagine I have this function that, given a year, it has to print 1 day per each of the year, and this actually works. This actually prints aloud in the console per each time of the year. But now suppose that, I don't know, 6 months or a year passed since I first wrote the function, and I find myself revisiting the code again. And something is not quite clear. In particular, this line is not actually very declarative, and I find myself trying to reverse what it's trying to do, and I say, okay, maybe it's trying to figure out if the year is divisible by 4, and now by 100, it's trying to do something, and if that condition is met, it's adding an extra day. So I say, maybe it's trying to figure out if the year is sleep or not. But that's the problem. The fact that I had to guess is the problem. I shouldn't be guessing anything. If I want to figure out if a year is sleep or not, I already have a function that resolves that problem for me, and I can just simply read the code. So something that simple as this is probably really powerful, because this is probably the simplest kind of change you can make to the code that at the same time adds the most of the value. Remember that functions are the first line of organization in any project. Functions should do one thing, they should do it only, and they should do it well. So they should have a single responsibility. And the reason why this is a simple yet powerful concept is because it works as building blocks for other concepts on top of that. For example, code duplication. If we think about it, most of the time, code gets duplicated because of the lack of meaningful abstraction. Somebody that has a validation there in the code that it's an inline method or something, and then somebody comes and say, okay, I need something that is similar to this, so I will copy and paste it here, I will change the 1 by the 2, and I think, okay, I'm all set. But actually, without we knowing it, we perhaps duplicated code inadvertently because that code didn't have a proper meaning or proper label to it. And duplicated code is the worst we can have because it forces you to do parallel changes. And when you have to change something, you have to do it many, many times, and you forget one of them, you have a bug, and there is a problem. So we actually want exactly the opposite. We want that for every part of the code, there should be one single place where to make a change at any given point of time. And that was the so-called DRY principle, which stands for don't repeat yourself. And in order to achieve this in software engineering, there has been many improvements or enhancements. For example, libraries, frameworks, tools, design patterns, etc. And those are great, and we should keep them in mind when designing our own code in Python. And when it comes to Python, we can say that we can have a so-called extra tool, which are decorators. I'm not talking deep about decorators because that's probably a topic for another talk, but basically the high-level idea is that there are functions that can modify our callables in the code and return a modified version of the original one. And we can see that how we can use that to our advantage in order to remove duplication. So consider this scenario. Suppose that I have to maintain the status of a database, and for that I have a script that someone else is going to be called, and we are written on this API. So the idea is I'm going to be executing every command in the sequence against the database, and at that point, if an exception occurs, I'm going to log the exception and return -1 because that's the agreed status call. And if everything works fine, I'm going to log that completed successfully and return 0. And this actually works, again, just at the beginning. But now I have another requirement, which is I need to move some records from a table to an archive table in order to move historical data. And I say, okay, I can do the same with 2 commands of SQL statements. One which is going to insert the archive data, and then I'm going to delete the affected rows from the main table. But then the rest of the logic follows the same pattern, and it's actually the same code as before. We can see that, again, it's executing every command in the sequence. If an exception occurs, it's logging the exception and returning -1. Otherwise, it's returning 0. And now we see the problem. We see that when there is a second requirement, the code was not extensible enough. It was repeated. And the reason why it's duplicated is probably because it didn't have a proper name or it didn't have a proper label to it. Instead, it was anonymous code trying to log something or return the status code, and it was tempting to do this duplication. So now I'm going to create another function, which I'm going to call DB_status_handler, and it's going to encapsulate that logic. And it's going to be a decorator, and details don't matter, but the high-level idea is that it's going to assume that it's decorating the original function that it's going to receive, assuming that function returns the sequence of commands that need to be executed with the database. And this is going to encapsulate all the logic. So DB_status_handler is in charge of running all the commands on the database, logging an exception if something went wrong, and returning -1, or returning 0 and logging if everything worked fine. And now the previous 2 functions can be changed for something like this. I only have to apply the decorator on top of the function definition with @DB_status_handler, and then I can change and remove all that logic away and just put the command that needs to be run in the database. And now by doing so, we achieve 3 things, actually. First, we put a name to something that was previously anonymous code, something that didn't have a name. Now it's called DB_status_handler. It has one rightful place. Second, there's a separation of concerns. Now, the previous function only knows about the login and the error handling and knows nothing about the commands, whereas this function has the exact same opposite behavior. These only know about the commands they're going to be running and don't know about the logic of the error code handling. And third, and most obvious, well, we remove the duplication because now the code is defined in only one place. So by using decorators, we actually separate the concerns, and we remove and abstracted away logic that was repeated and exposed. So there are many cases on which we actually have to deal with implementation details, which as part of accidental complexity. Scenarios in which we have something that is part of our core functionality, something we actually want to do, and some other accidental complexity that in general is related to technology that we cannot escape from. And we want to keep that as separate as possible in order not to entwine things that might lead to code being harder to maintain. So we'll see what Python has to offer on this. So consider this scenario now in which we have an online application with players playing online. And this object represents the status of a player at a given point, basically the point that it has, etc. So after a game finishes a match, I want to update the points with the new points that player scored. So I have a method like this, which is accumulate points, and I pass the new points. But if you take a look at the implementation, it's not actually something very nice, because we see that it's handling with Redis, a connection with the key, 0, which seems to be a default value, then follows what I actually want to do, which is accumulate new points. And then it seems that I'm, again, dealing with Redis and the key, etc. So it turns out that this is not highly expressive. So if I want to get the points of a player at a given time, I must just write points. If I want to set them, I can do points equal anything, like I do with any other regular Python variable. So the previous example, the accumulate points, well, it turns out there's nothing particular about it. It's just plus equal 20 or any number, which makes things much more simpler and abstracts that logic away. So in order to achieve this, we can implement this with a property, which is a built-in decorator in Python. And I will encapsulate all the details of the technical parts into there, so the user doesn't have to know there is a Redis connection or etc. And it doesn't even have to know or agree to a specific API. It only knows that there's a point, and they can accumulate or try to assign a variable, and it works. So in general, it's a good idea to use properties for this set of cases when we have to do some computations on other attributes of the object. And basically, we should prefer this approach as opposed to writing custom getters and setter methods, because that might be well for other languages, but in Python, it's just better to keep things simpler, because it's more Pythonic. So the idea is that with this in mind, it also becomes easier to read and also easier to test, because now we can unit test this with any object that has a dot point attribute. It doesn't have to be a real one. I don't have to have a Redis connection or patch it or mock it. It's just a simpler way of solving things. Now imagine the case of we have a searching algorithm. Now suppose I have an online application that sells products online, and this object, this class represents all the products that I have stored by categories. And at some point I have a view that looks like this, and is in charge of handling the scenario when a customer wants to make a purchase. And this is too complicated, but I go through the hassle of reading it. And near the if statement, I found something that is like a clue, which asks if product available in stock. And I see the problem, which is pretty much at the beginning, because again, I'm reverse engineering the code and trying to deduct what it's trying to do. So I say maybe those all previous lines were actually trying to figure out if product was available in stock. And now, if I want to figure out if a product is available in stock or not, I might rather just simply write that, if product in current stock, which makes perfect sense. And it makes the code to speak in terms of the domain problem. This is actually almost as reading a business rule in the code. So in order to achieve this is because every time we write something like this, if product in current stock, Python will translate that and call the magic method contains, and will pass the object as a parameter. So now with that idea in mind, I know that, okay, maybe I can implement contains in stock class, which actually, by the way, makes perfect sense. I move all my searching algorithm and my logic there, and now I can rewrite my code in much more expressive fashion. So sometimes the answer is in the magic method. Sometimes there's a magic method that makes your code much more expressive and easier to deal with. In other cases, we have to maintain state, meaning we have to run our first logic, the business rules. And we also have to keep the system in a consistent state. Sometimes that means, for example, we want to make sure we don't leak file descriptors, or we don't leave connections open to a database, or we want to remove temporary files, etc. And again, we shouldn't fall into the trap of putting everything into the same place, because that will be harder to maintain and to test. So consider this example. Let's say I have to run a backup of my database, but the backup is offline. So I have to stop the database, run the backup, and then I will start again. And one way I could do this is by means of a context manager. And context manager are a fairly simple protocol in Python that only have two methods, enter and exit. And when I do something like this, I'm going to put the code that stops the database into the enter. So I use this with a with statement. So when I run with and an object that follows this protocol, Python will first run the enter method. So there I will stop the database service, which stops the service in Unix. Then it enters the context manager block, and then I will run the backup. And the function that runs the backup only does that and nothing else. And then after the last statement completes, Python is going to exit the counters method and is going to call under exit, even if an exception occurs, which makes things even simpler or easier because I don't have to deal with exceptions or error codes, etc. And in that code, I put the logic of starting the service again in order to make sure that I'm leaving the system in a consistent state no matter what. There's a slightly better way to improve this and save some boilerplate in some cases by extending the context decorator interface available in Python 3. And if you implement under exit and enter, you can then apply this as a decorator. And this means that every time the function is being called, it's going to be called inside the context manager, so you don't have to put it. So it's a nice way, and in some cases you can use it. So the idea is that, in general, Python code means to use the features of a language. That means to actually make sense of the features. And a good idea to know that we're achieving this, if you're writing code in a way that blends well with Python reserved word in a meaningful way, pretty much like the if product in current stock example. And you can do the same with for loops or with, I don't know, with context managers, etc. So that's probably a good thing to keep in mind. So to wrap up, we can say that in general, the best way to to achieve Pythonic code is to actually take advantage of the features of the language. That means sometimes using a context manager, sometimes using a decorator, sometimes there is a magic method for that. The important thing is to keep that in mind and to keep the code readable, because this is what we should care about when doing a code review on evaluating a pull request. On a side note, there are other tools you can use for having a good code, which are, for example, all the static checks or compliance with the standards. But the reason why this is different or separate is because it's not actually about having PEP8 or any going style. You can be 100% compliant with PEP8 and still not have a Pythonic code, because again, Pythonic code is achieved by using or expressing the code in meaningful ways. So these are things that we should leave to the machines or to run automatically with scripts or bots as part of the continuous iteration and not worry about in a code review. In a code review, we should ask things like, is this code readable? Is this code understandable? Does it make sense? A new person joining the project will be able to understand it the first time it reads the code. So that's actually a good use of our time. It's usually a good idea to put docstrings or function annotations in order to hint your readers about the functions or what they expect in order to receive or return, because Python has a dynamic nature and they make sometimes things harder to trace. Everything I mentioned about the code also applies to unit tests, because in the end, unit tests are part of the code base. And also having unit tests and writing unit tests will help you write better code, because things like in the first example, like the function that takes about the leap year, that will come cleaner or more clear in a unit test. You want to test that and you will realize that it's coupled. And naturally you will realize, oh, I need a function to separate this. So by having unit tests and by having the mentality of writing tests, you will naturally follow a more maintainable code. Finally, we have some tools that we can use. For example, PyCode style, Fleck8, PyLint, that will give you metrics about the code. In particular, the last two, PyLint and Radon, will also give you metrics about, for example, cyclomatic complexity that you can use as a head start in order to identify places of the code that need more refactor urgently. And also Koala, which is a tool that lets you even define your own rules in case you have a particular standard, and can also work with the previous tools as a backend. So the idea that I want you to take from the talk is that it's not about standards or it's not about the code. It's not also about knowing all magic methods by heart or all features of Python. It's about having like the right mentality of the mindset of that I need to look for something in Python. Like writing that there's always a better way or a more Pythonic way. And a good clue to find that is like usually, for example, try to take a look at the methods of the data structures or objects that I'm using, and that will give you sometimes the clue of what's the better way of writing tests. For example, if I'm using a dictionary, try to see what methods provide dictionary that can help me solve the problem, because most of the time, the problem we're trying to solve is already addressed by Python. So basically, if you are particularly interested, there are some resources that I use for the talk. In particular, the two books, Clean Code and Code Complete, are more general of software engineer. They're not specific to Python, but they're also very good sources for this talk. Let me know if you have any questions, and thank you very much for listening to our video. Thank you.
Perfect. Thank you for the talk. It was pretty quick, so we have some time for the questions. I think that there is we have one Slido question. So, doesn't following dry and using decorators reduce readability? Wouldn't it be better, be more readable to call a function to execute list of statements in your example?
Yes, actually, first, examples are just for illustration. It's not real nor practical Go. Yeah, so maybe the examples are sometimes a bit forced. The idea is that decorators in general are good tool for reusing code or duplicating code. Sometimes that means to hide or encapsulate. Yeah, it could be the case, but in general, it's worth it, or it's even worse to have code that is duplicated. And also, I don't think it reduces readability because we all know basically how descriptors work. So if you think that something is too magic, you can inspect the decorator and see that the logic is there. And also, it's not the only way of reusing code. I mean, I could just have used another function, and that could have worked as well. I don't know if that answers the question, but yes, basically,
We can ask if it was sufficient answer.
Maybe the example, the examples are just toy examples. They're not just actual productive code. So in that case, maybe, but in general, no.
Okay, cool. Does anyone in the audience have a question that I would just give you the mic? Okay.
Hi. Are there any machine learning tools to automate making code clean?
Machine learning tools?
Yeah, something that reads the source code and try to figure out how to make it cleaner to apply, I don't know, some design
Not
patterns.
that I know of. No machine learning tools. There are static analyzers, things like, for example, PyLin or Radon that can tell you, for example, analyze the cyclomatic complexity and tell you this code is too complex, it has too many statements nested, etc. But it doesn't use machine learning, doesn't use artificial intelligence. I don't know of something that uses artificial intelligence for that. I know there are tools, but they are just regular tools that use, or maybe use the AST or something like that, but not like PyLin, but they don't use AI as far as I know.
Okay, thanks.
Perfect. We have another Slido question. Are you familiar with Solid? Had you tried to port it to Python?
No, actually, no. No, I haven't implemented in Python, no.
That was a quick one. Do we have some more? Anyone? Okay. So I think that the talk was so self-explanatory and so full of information that everybody got their answers. But if you will have any further questions, you can definitely reach out to Mariano, because he will be here tomorrow. He will have another talk in the main hall. So he will be available in case you will have any further questions. So, well, we finished a little early, so you can go check the paper and sign up for the lightning talk. And now we will thank Mariano and all move into the main hall, okay?
Okay.
So thank you very much.
Okay.
Thank you. Thank you very much once again. And yeah, see you soon.